Hello, hello. We are already part 4 of the conference. Oh, nice. I see some action in the background, in the backstage. Yes.
Hello.
Great
I
job.
feel like now the theme is to have
Yes,
eye mask.
exactly. And then we can fall asleep shortly.
Really
Cool.
like
Yeah,
yours.
no.
Because
Yeah,
mine is just
exactly.
a,
The
uh
plain
free
one.
gift
This
from
is
the
this
train.
is yeah, this is the fun one. So cool. We have another section now. We still have a couple of minutes before we go. We do have more people that were leaving before. So I really curious. Drop under the YouTube comments. Where are you joining from? I am currently joining from Berlin. And you, Chuck, maybe you can repeat where you are.
Yeah, I'm in Barcelona, which is
Oh, so
this is
nice.
not my home. I'm home away from home. Because I just finished joining Pi Day today, Pi Day Barcelona.
Nice.
Um, yeah.
That's really cool. So yeah, let us know, people, where are you joining from? We know that we had already people from the Americas started to join since the last part of the conference, and now in Central European time is already almost 10 p.m. Not so late, but late enough to be cozy and grabbing some hot beverage and enjoying the next talks.
Yeah.
Okay.
Yeah, this is the mask I use when I'm traveling. So I got that from. So this is actually the logo of the Caledonian Sleeper. So it's a
Oh, I didn't
night
know.
train going from London to Highland in Scotland. So
Oh, nice. I didn't know. I thought that it was the one that they give you in the hotel or maybe in the plane.
no, hotel doesn't give you hotel doesn't need eye mask. You have your own
Maybe you,
room.
you asked for one. Like, can I have one? Okay,
Yeah.
cool. So maybe let me share here. We will have now a couple of talks that are recorded, and that doesn't mean that they are like worse or anything. They are really cool. And the first one, you already can see the title here, is the infamous issue, the famous talk that we had in the issues in the morning. But Jesser was kind enough to quickly record the talk, submitting it. We double check it, and everything should work fine now. I have it here ready for you to learn about it. It's a really interesting topic, to be honest, because I mean, it's the first time that I'm looking into SQL, Python, and async on the same phrase. I don't know about you, Chuck, but it's for me was like, what? You can? And so, really curious.
Yeah, I'm looking forward to watch it.
Cool. So I think that we're already a little bit, a couple of, 1 minute ahead, running late. So maybe just to avoid the people that is waiting for this amazing talk, maybe let's start. So I will remove you and myself and be right back after this talk.
Hello. I'm sorry for the issue we have this morning regarding my talk of async database. So my discussion today about the asynchronized databases. We're gonna discuss different stuff regarding the asynchronized code, synchronized code, databases, SQL, Python, and stuff. Bunch of stuff regarding the Python environment and the new design of the new stuff in Python. Let's start. So here is our agenda for today. So my first point is like, why not asynchronize? Why asynchronize? Behind the logic of ORMs, pros cons for ORMs and stuff. I'm struggling which ORM I'm gonna use. We'll see some ORMs and discuss them. So, and also a quick look into ORM Dontic, ORM that I built, and by the end, just a schema about the overview of this talk. So, who I am, maybe people know me, even know. So I'm Yasser, or call me as I'm an experienced software engineer, self-taught, and I started doing code 5 years ago, 6 years ago. So I have like a much of bunch of stuff I work on them before and also now. I do also consultant for a bunch of companies and startups. regarding what they need in FastAPI, Django stuff, and the others. You can find me on Twitter or on GitHub. Just like copy the username and you'll find me. And let's start. The first part I want to talk about is like, we always start with the bad and go to the good side. It's like a point we don't have a heart attack or something. So let's start with why not asynchronize. So when it's come, why not asynchronize is like, why I will use asynchronized code. Why? So this is like first question I will ask myself: why this code gonna be asynchronized, or why I'm gonna build my model is in a synchronized way? Why? So before that, in many cases, we don't need asynchronized code or asynchronized ORM or asynchronized databases or stuff, because the main reason is like a bunch of people doesn't know how to code it safely and correctly. It's one of the issues that people may take care of it. So we all learn Python in the same way, like YouTube, Google stuff, courses, documentations. We code synchronizedly. 3 years ago, it was like the famous stuff. Now it's like asynchronizedly. It's like the main one. No, this is why. Because the modeling database also are so fast when the query is simple. So I want a query just to select, like, for example, OLs from a specific course. So why I'm gonna make complexity and use this as an asynchronized function or a synchronized query? Why not just like write my query normally and boom, I got the result. So when it comes to simple queries and stuff, it's much better if we use just synchronized code. And this kind of application usually deploy the database in super reliable network. So whenever right now in the modern startups, modern companies, stuff and like that, you will find a bunch of new technologies like AWS, Google GCP, Microsoft Azure, bunch of them. So like they are high technologies with a high, you could say, performance when it's come to I deploy my database and stuff. In this case, like it doesn't make sense to use asynchronized and stuff. So it's like you could say, hi, I want to use Essential, or I want to just asynchronized stuff just because I love that, or asynchronized ORM or something. Yeah, and for the pros for the synchronized codes, like synchronized programming is best specialized in reactive systems, while it's simpler for developer to code and is recognized by every programming language. Sync is resource intensive and can slow things down, which means everyone like can code just normal code, like not asynchronized stuff, and make things and make weights and understand the model, understanding how it's work, like this process then stop until this gonna complete and stuff. So synchronized programming is like we use it like in a bunch of applications, bunch of big tools, bunch of stuff that doesn't need to have a waiting moment or a function that's need to run progress with another function. So bunch of stuff. That's why it's like let's keep it simple. Use synchronize and everything gonna be good. So if it's not like something that's depend on asynchronized systems or asynchronized logic, much better if we use synchronized code. Now let's go to the asynchronized part and why we need to use the asynchronized part. So when we said asynchronized, we mean like a multi-threading model that's most applicable to network and communication. Let's say we have, for example, a small system for chatting internally in the company itself. So like, for example, let's say I'm a CTO and the other one is like the software engineer, the team lead. So we are talking about a bunch of stuff. I send a message. So the other team gonna wait me until I complete my message and send it. This is like gonna be so weird, maybe especially if like I have not a complete idea or something like that. So it's much better like to block me and say, like, for example, the software engineer says his idea and stuff. This is what can be a closest like logic to asynchronized, like chatting system between that. It's much better to use asynchronized code, which means it doesn't block further execution while more operations are in progress, which means like my progress not blocked before because that. So it's everything gonna run in the same time. With asynchronized programming, multiple related operations can run concurrently without waiting for other tasks to complete. That's what I mean. Like when I, for example, I'm taking the lead to talk, and I mean, like, for example, an issue in what I'm saying, like the other one can just obviously like correct me or like complete what my idea or stuff. This is like concurrency in the discussion or something like that. During the asynchronous communication, parties receive and process message when it's convenient or possible to do, rather than responding immediately upon receipt. Is like that what I mean. In the end, like texting is like a synchronized communication method. One person can send a text and the reception can respond on their leisure in the meantime, which means, like, for example, let's see it as WhatsApp, Instagram, Twitter, chat, stuff like that. You write a message, someone else writes a message in the same time, everyone writes a message in the same time. So this is not gonna block someone from now or like that. This is like one of them. And for like, let's say, famous example or something like that, responsibly, I would agree asynchronous planning, the shopping application, like let's see Shopify, let's see Amazon, stuff like that. It's like when you use a pool, like a new order or something, the font size like should increase instead of first waiting to load the history and update the font size. Like asynchronously programming can make it both action happen, which means the font size and loading the history of and updates for the others orders and stuff. That's why like asynchronized code much help us to make things work progress one under the other under the one. So that's like that. We're not gonna wait everything to operate on a slow down level. So it's everything like operates in a progress. Every progress gonna run. Every progress are gonna run separately. So that's why asynchronized, it's much used in systems like real time systems like chat, like shopping application, real time feed like Facebook, stuff like that. So it's much better to use stuff in asynchronized mode or asynchronized ZMO stuff. Let's see now the logic of ORMs to take both, like how we get from asynchronized and the ORM. So now we understand like asynchronized, difference between asynchronized and synchronized. Now let's understand the ORM and see like what is ORM and SQL level stuff, and let's like make them both in a mix. So the ORMs first is like object relational mapping, like a mechanism that make possible to address, access, and manipulate objects without having to consider how those objects related to the data source. How we can understand it is like, see it as a table. We have a table of data, or for example, name, phone, address, and stuff. We don't know like who belong to or something like that. We're gonna just use like this mechanism to transport this data into the database without like writing a lot of SQL stuff, writing a lot of stuff to make this possible. And it's like just some easy steps, take this and put this. But in that mechanism, have the possibility to understand both level of the database gonna receive and send also, and level of the clients who create the tables to send them. So this is how. For example, here's like a completely imaginary case, like how you have a book class, you want to retrieve all the book of which of the author is Linus. Mainly will do something like that. I mean, in SQL level, but also in a code level. So you write like, for example, book list, you create the list, the SQL, you write your query, select book from library where the author is data, you query the SQL, and now you look over it to add or to select or to get or to retrieve. But in the ORM level, let's say in the ORM level, for example, we can retrieve it just with one line. Create just book list equal book table, where we have already the tables assigned with the data and stuff and the fields and the table's name and stuff like that, and we query that. And we said like to this query, I want the author that called this, and we run this query. It's give us like the results. But how it's work is like when it's transport this query to multi-level, it's it like it's a SQL code, a SQL progress that's sent it directly from the ORM itself to the database. That's the language of database understand it, which means understand it and responds to the ORM with the result that it wants. Yeah, so this is the books that Linus has. And this is how like ORMs works. and especially this is the logic of them. But not much of times ORMs are good. Not much of times like SQL is good. But we said SQL is the main one. How we gonna interact with the database, structured one. But ORMs help us to understand both level, the language level and the database. For that, I create like the pros for that and the cons. For the pros, using ORMs save a lot or a ton of times because like don't repeat yourself. You write your data models in one place. Let's see it, for example, if someone here, I guess everyone here gonna be familiar with Django, the MVC format, the model view controller. We have a place where we assign our models and stuff like that, and we don't repeat them. Like we don't write every time like the models in several stuff. Write it in one place. We can update them and migrate them directly. We can reuse the code, and the bunch of ORMs now, the bunch of the ORM have a ton of stuff done automatically. For example, the database handling, maybe the level of error handling and stuff, maybe also the internationalism, and a bunch of stuff. It forces you also to write an MVC code when you separate like the models and the view and the controllers and the OT stuff in a separate way, which like make the code at the end like just clean with we can say a common format at the end. You don't write a bunch of times like SQL and you don't end up like writing a bunch of queries. You need to check them. You need to run this query in a SQLite database to test if this works, if this not, if this, what if this gonna cause us a SQL injection? What if we didn't like properly make our SQL code safe and stuff? Most of web applications really suck at it. I mean, web programmers and people who do programming, I mean, the new generation programming doesn't get deep stuff into SQL. And that's why it's treated like a sub-languages when it's reality, it's a very powerful and complex one. Sometimes like using program statement transactional really is called. Using ORM library is more flexible because it's fit in a new natural way of coding. For example, in Python, we have a bunch of libraries. We're gonna see them at the end. It's abstracted DB system, so you can change it whenever you want. A bunch of times, like we have the options. Let's say today I create my SQL stuff in SQLite. I wanna deploy them. Of course, I'm not gonna deploy SQLite database. I'm gonna use Postgres. So just changing the URL. And everything gonna work fine. This is how. The model is weakly bound to the rest of the application, so you can change it or use it anywhere else. So I mean, like the model is separately between everything, every part of our views, controller stuff. It lets you use the OOP. The governance like data inheritance without a headache. Like we all love OOP. We all love like. Coding stuff in general way to find like the easiest way to find a bunch of stuff. Yeah, so this is like one of the I see them as a pros for using ORMs, but for the cons, it can be a pain when you have to learn an ORM and not the tools, which means you need to understand, for example, in Django ORM or SQL Alchemy or a bunch of other ORMs, you need to understand them deeply to know when to use this and when to not use this. And this is how you have to set up it always. Like if you didn't set up everything good, you gotta have everything separately. Have a bunch of issues there. Well, also in the performance level, if we see SQL performance, it's much lightweight than the ORMs. So if we own like a big projects and we use like a bunch of SQL stuff, it's gonna make them lightweight, not take a bunch of times. But when we write like queries with you depend on ORMs. Sometimes it's gonna cause us a lot of tons of waiting just to perform this, especially in big projects, especially in really big projects that scale. It's abstracted DB. While it's okay if you want like to don't know the scenarios or what happening behind the scene, it's a trap for new programmer that can write very greedy statement, like a heavy hit of for loops and stuff like that. So sometimes understanding the abstract, it's help the developer to know himself, to know a bunch of issues, bunch of stuff. So like this is gonna be helpful to not use the ORM until you want also to explore the what happened behind scenes and scenarios. Yeah, I'm so glad now what ORM I will use. We have in Python a bunch of them, especially like I'm now in a Pyjamas, which means like a Python conference. My favorite, or the normal state everyone uses, SQL Alchemy. It's like the famous one, written by Mike Bayer and SQL Alchemy team. Like one of my favorite ORMs exists. Like, I use it, and the Django ORM too. It's like from the Django project itself. Is like the one that uses in Django, and it's also good and amazing. We have Peewee, we have Pony ORM, we have SQL Object, we have Tortoise, we have other ones like I try to remember one of them. Like I have also SQL Model from Sebastian itself, the creator of SCPI. We have ORM Don't that we're gonna discuss about it. It's like something that I inspire from a bunch of other ORMs built, and I'm trying to make it using a bunch of tools. So it's important until now, like just asynchronous code. There is other tools like Storms, a bunch of them. And if you go like for other languages like Java, PHP, JavaScript, other stuff, you will find other ORMs also support a bunch of stuff. So that's why we have multiple stuff we use. You can just go take some time, play around sometimes in the database, into the documentation itself, read it, understand what happened, see scenarios, try them into your local, and with that you can understand SQL Alchemy or other ORMs that you see here, or the other ORMs, you know them. So yeah, I forget also to mention Piccolo is one also of the good ORMs now in the new generation. I love it, by the way. It's like if I want like maybe now my stack, maybe if I want like to start a new fast API project, like my own stuff, I could use it with the Piccolo and like that. It's like one of the amazing. And also there's Tortoise or SQL Model or SQL Alchemy, the base one. Yeah, now let's pass to ORM Don't Check one. This one I baked this one. It's like based on PyPika. It's like Python query API. Like everything, take the abstract of SQL stuff and write them into queries and make things facilities. And also powered by Pydantic and SQL Alchemy. Everyone know that Pydantic, the model stuff, how Pydantic help us, how Pydantic is amazing and stuff. And SQL Alchemy, it's highly inspired by SQL model created by Sebastian. And yeah, it's sensible. Like you can just write code that will work underneath. It's combined a bunch of amazing tools. Like you can extend other features are in Pydantic or SQL Alchemy, PyPika itself, and try to simplify the code, like writing minimum and reduce like a bunch of stuff like code duplication. Also give like the developer the best experience. It's extensible. Yeah, I mean, like you can use also the power of SQL Alchemy on top of it, or PyPika also. Short queries, like we're gonna see a quick demo, maybe like just a quick demo to see how stuff works here and understand like the schema of it. So yeah, the quick overview before the demo, I guess we can like just like abstract stuff. I'm gonna for example just like show you a design of it. Maybe let me just change my output screen, because I was doing like this one. Not just this one. I'm gonna use yeah. So I guess this one gonna work fine. Where is it? Yes. So I'm sorry for that. I cut it and complete. So to complete what we start is like I told you like a demo to understand what is ORM logic. So ORM logic, like it's help us just to create, for example, a SQL Alchemy engine. It's baked with SQL Alchemy when you create the engine, just the connection database, you call it, and you create the database. For creating the tables, you just like create your model, your Pydantic model normally, like for example, flavor or something else like coffee, car stuff. You create that table normally like in Pydantic, but you add a parameter, stuff like database, the table, you add it accepts primary key, the index, the foreign key, back reference, unique constants and stuff. It's like here we call the decorator and stuff. And also, yeah, it support other queries. Like when we initial the database, we answer the database. For example, this one for answer, it's like answering stuff is like answer the flavor. For example, we create a flavor name. It's called vanilla. We answer directly. Database flavor answer. Answers vanilla. So this is how we do also searching. Find one. Find many. Find in depth with the to search with other stuff like where, order by, order limits, offset, and depth stuff. We have the update and the upsert. Yeah. Also count and delete. And I'm still working on develop it. Also, people can ask if they have some experience with SQL model and stuff. They ask what is the point of difference. Yeah. So, for example, in the multimorphism, it's like inherited from Pydantic base model SQL model and use a modified SQL Alchemy base model as a meta class. But Orendontic use a wrapper or decorator to make Pydantic base model behave like database table as well. For the database connection, SQL model is not built like it's handled with creation sign. The Orendontic just take the screen. It's like just take the string as a constructor parameter. It's like async by default. And for the API stuff, is like you typically interact with both the session objects and the SQL model object. But here in Orendontic, you interact like PonyORM stuff with the database abstraction. The syntax is like similar to PonyORM, which means like you can write queries into database with the Python generation expression and that stuff. So it's structured like a SQL queries. In the background, yeah, SQL model is created by Sebastian, and this one's like just new and still in development stuff. Yeah, so to complete that, here is a quick overview of what we can understand from both like ORMs and synchronized code. So synchronized processing, just remember like this is like database stuff. You gotta need to understand what's happening is like process A and process B. So it's a synchronized code. It's gonna just call the process A. Process A is run when we call the process B. It's stopped. We run the process B, and again we go to the process A. So this is how it's working in synchronized level. In asynchronized level, it's work like we have the process A and the process B. We run the process B. Both of them run. We complete them, which means we run process A and process B at the same time. And this is how it's like. Hope like you got understand what happened here generally. Yeah. So this is the whole idea and a bunch of idea I would like to share with you regarding the asynchronous stuff and the ORM stuff, just to make sure everyone understand them. Yes. So if you have like a question, I'm sorry if I didn't like join the meeting because of the talk because of the issues of connection and stuff. Yeah, if you have any questions, you can find me on Twitter, just THESR1 or just TS123 and you will find me. And let's catch up there. Thank you so much and see you on another.
Okay, so I was muted, of course. Usual stuff. I'm sorry, my brain is functioning 0.5%. Yeah, so thank you very much to Yasser for being kind enough to record that talk. It was supposed to be the first talk of the conference, but we couldn't do it. But now you have all the answers to all the questions if you are maybe familiarized with that. We do have still a couple of minutes for the next talk, which is also quite interesting. I went to the preview of the talk and started to move around, and it's really cool. I think that the way that the presentation is being made, it's really interesting. And if you like to do good presentations, maybe you like to copy some of those ideas. So yeah, be right back in a moment and with the next talk. Okay, that was quick, but I managed to have a sip of my coffee. So the next talk, as I was mentioning, is recorded as well. It's by Jason Ko, and it's also, I don't know, I really I might sound biased, but the topic is really interesting as well. I hope that you enjoyed the talk. I will try to share it now. So this is the one, and I hope you enjoy.
Hi, everyone. Welcome to our session on graph databases for Monty Python developers. My name is Jason Koo. I'm a developer advocate at Neo4j. And as I presume everyone here knows, the Python programming language was named after the BBC comedy group Monty Python and their famous TV series Flying Circus. Now, the 6 gentlemen who were responsible for creating, writing, and acting in this series also went on to create a series of movies. Their second movie being Monty Python and the Holy Grail. Now, this movie was produced in part by a man named Mark Forstater. Now, Mark went on to actually sue the group later on when they created a musical based off of the movie Monty Python and the Holy Grail. That lawsuit resulted in enough money that the group decided to get together and produce a live show to help pay it off. Now, that live show was so popular, it got extended to, I think, 8 additional events. Basically, it went from 2013 to 2014, which was the year that Fernando Perez and Brian Granger released Jupiter. Now, this short traversal story is an example of the type of information you can glean and traverse through in a knowledge graph. And a knowledge graph is an example of what you can do with a graph database. Now, graph databases. Okay, technically, what are they? Okay, so in broad terms, they are a type of NoSQL database, alongside with document, key value, and column family databases. And here on the right, I've listed some of the many famous companies and services that are available for these other NoSQL options. Now, what makes a graph database different than these other data stores is how the relationship data is stored, right? So we've got 2 main things in a graph database. We've got nodes and we've got relationships. If you're coming from a graph theory background, and a node would be a vertex, a relationship is an edge. And nodes are, you can think of like typical information you would have in a tabular database would be like one row in a table is a node, right? So here, for example, we've got the Black Knight. He's a node, and we've got the bridge as another node. It's a location, and here relationship is creating a context between these two nodes, right? So here we can say the Black Knight is guarding the bridge, and in a graph database, the relationship component is a first-class data citizen. So it is stored along with the nodes. Now, this is different from other databases that typically don't store the relationship, right? That is something that is created temporarily by a join statement, for example. Okay, so in a graph database, you can also put properties with both relationships and nodes. So, for example, we're giving a name to this node, which is the Black Knight. We could attach an image URL, date of birth, social security number, et cetera, and relationships can also be given properties. So we could weight the value of him guarding the bridge, right? Like how long has he been guarding the bridge? How well has he been guarding the bridge? This can be put into a graph database. And this kind of graph database that stores properties with relationships and nodes are known as property graphs. Okay. Graph databases in general. So some of the general pros is, again, you don't have to do these sort of fugly joins. And the schema is optional. So you, of course, having constraints and indexes will make queries much faster, but you can just start putting information right into a graph database, and you can give labels to nodes or assign types and properties after the fact or down the road. So it's very easy to iterate through your data model and your schema. And if you're using a visualization tool, data analysis and data discovery is actually quite intuitive. So, for example, say we want to play a complicated version of the Kevin Bacon game, where we want to find the relationship paths between all the main actors from The Matrix with the main actors from Monty Python and the Holy Grail. Okay, so if we have this information in a graph database and we query it, we could get something like this. So here on the far left is Monty Python movie and 4 main actors, 4 of the 6 Monty Python crew. And on the far right is The Matrix with 4 of the main actors, Lawrence Fishburne, Carrie Ann Moss, Keanu Reeves, Hugo Weaving. And here we can see in the graph, we can see very quickly that there is no one-hop connection between any of the actors, right? So there's at least 1, if not 2 degrees of separation between the 2 sets of actors. And one of the more interesting connections is actually at the very top, if you can see it, with Sean Connery, who had worked with Terry Gilliam and actually Michael Palin both together on Time Bandits, and then also with Lawrence Fishburne later on Just Cause. So, and Sean Connery's connection with Time Bandits is actually interesting. He was written into the original script as a joke because Terry Gilliam and Michael Palin didn't think they would actually get Sean Connery. But it ends up, Sean Connery was actually a fan of Monty Python. And so when he had caught wind that he was actually written into the script, he said yes immediately. And Terry Gilliam, I think, attributed Sean Connery as saving the movie because I think the year that it came out, it was competing with quite a few interesting movies. Anyways, so this sort of information you can quickly peruse through when it's attached to a graph visualization tool. Okay, some cons. So you wouldn't want to use a graph database for pure transaction, pure logging information, right? So if you need to record data, but you don't plan on really analyzing the data immediately or anytime soon, then a graph database isn't going to help you. Isn't going to be above and beyond the other options out there. Okay, and if you need a quick cheat sheet, I love this graph from the Manning's book, Introducing Data Science. So here we've got XY chart here. So on the y-axis, we got the size of data from small to large, and on the x-axis, from simple amounts of data to complex amounts of data, right? So if you are just wanting to store a ton of data, but it's fairly simple, of course, use a key value store. But if you want to contain really interconnected complex data, you should really use or consider a graph database. Now, what's an example of like complex data? So fraud detection is a great use case for graph databases. So if you're trying to detect fraud, right, you're hopping through multiple domains, right? Maybe emails, documents, banks, address, location. There's quite a bit of various different, typically siloed pieces of data that you would want to pull together to look for fraudulent behavior. Another example of this would be like trying to build a spam detection system, right? So spam, by the way, originally began with a Monty Python skit, also just named Spam, I believe, and through quite a, I won't go into it, but this scene, this skit, ended up becoming what we now know as spam in terms of email, as unwanted, unsolicited content, which actually drove the company that produces spam a little nuts at first. And they tried to fight it, or I think they tried to sue tech companies. I forget the exact details. But anyways, they were totally against this, obviously, at first. But eventually they turned around. They just embraced it, which led them to actually sponsor the creation of Monty Python's Spamalot musical that ended up getting them sued. Okay, so who are the major players in this space? There are quite a few databases now. The space has been around for a while. And according to DB Engines, which is a website that uses a number of various other resources and then combines it all and uses some magical algorithm to score the different graph databases. And then here we've got this chart here. So here we're just listing the top 10 graph databases. As you can see here from their ranking, Neo4j and Microsoft's Cosmos DB are at the top, followed by many other still well-known graph databases. Okay, so if you never used any graph database and you're looking to start one, I would start with obviously this list. But something to obviously consider as with any sort of tech project is what is the skill set of your existing team, right? Like, does anyone have existing knowledge of graph query languages on their own? Are you an AWS house? So take that all into consideration when you look at this. But if you just want to start from scratch, this is DB Engines is a great place to start looking. Okay, so graph databases in general could be broken up into three broad categories. We talked about property graphs earlier. The next one I'd like to talk about are semantic graphs. Yes. So semantic graphs are a bit different than property graphs in that everything is stored in triples, right? So everything is a subject, predicate, noun, right? So if we have this node on the left, which is Ernest Scribble, right? Scribbler. So instead of attaching properties, you would attach this triple to assign a value to this node, right? So this node that represents a TV skit character, his name, the predicate name, is a string, which is Ernest Scribbler. And in the same fashion, you would tie a node to another node, right? Subject to another noun, right? So Ernest Scribbler went on to write the funniest joke in the world, which through the skit ended up being weaponized by the British government, so on and so forth. But you can see how this triple stores the information differently than a property graph. Okay, let me go back here for a second. And the last general broad category are multi-model databases. Now, multi-model databases aren't strictly graph limited, right? Because essentially, a multi-model database can have data stored in many different formats, right? Here, XML, CSV, JSON, and even other graph database formats. And the idea is to have a graph query language that sits on top and allows you to query through all those different document data stores. Okay, so those top 10 databases from earlier can be roughly broken up into these three categories. Some may kind of bleed into others, but generally these companies, these products are known in these broad categories. As you can see, Neo4j, the company that I come from, is a property graph. Amazon Neptune is considered a semantic graph, and Cosmos is multi-model. Redis, which I didn't put here, can be considered a multi-model database as well too, because Redis does allow you to run Cypher in a graph instance. Okay, so lots of companies, lots of products, which unfortunately means lots of different query languages are available out there, right? So it's kind of a zoo at the moment, but fortunately, smart people have gotten together, and there is a group that has come together to create a graph query language GQL standard, and it will be an ISO certified standard. This group got together in 2019, a few years back, and they are on track to have a official proposal or official spec by 2024, I believe. Now, graph query language, though it's when you read out the whole thing, it's basically the same as GraphQL. It is not the same as GraphQL, right? So GraphQL, of course, is the REST alternative that was developed by two gentlemen at Facebook. So it is a protocol for getting information, right? It's a REST API alternative. And now, to make things even more confusing, if you want to use GraphQL as the primary query language for a graph database, then there's a company known as dgraph that has created such a graph database that uses a flavor of GraphQL to query its database. Okay, so many options out there, but in general, GraphQL is not the same as the graph query language that is in development. Okay. The GQL is considering the future language based off these 10 popular existing graph query languages. Now, I'm not going to go through all of these, but I highlighted 3 that I think, if you have time, I would recommend taking a look into. So that is OpenCypher, Gremlin, and Sparkle. Gremlin is used both with Cosmos DB and Amazon Neptune. And Sparkle is maybe the oldest graph query language here, and it is used for the semantic graphs, right? The RDFs or triple stores. Sparkle's syntax is particularly unique because of that triple instance. And Gremlin is interesting because it has this builder pattern. So when you use the Python driver, your call looks exactly like the Gremlin query. So that's a nice feature. But I'm going to focus on OpenCypher. And the reason for that is I know Cypher better than the other query languages. Now, Cypher was originally developed by Neo4j, and then it was open sourced back in 2014. It is a declarative language that has ASCII art-like qualities. So above here, I've got an example query. You can see here we start a find or a match for a pattern, and then the pattern. So the pattern is made up of, you can see here, parentheses and brackets. Everything in a paren is a node, and everything in a bracket is a relationship. So you can see here, we're looking for a very simple relationship, right? Just looking for people who acted in a movie. And then we've got a where keyword as a filter. And we're looking for title of a movie that is The Matrix. And just return to me all the names of the people that acted in the movie. And in a simple movie database, just having a few of the key main actors, we would get returned this list of actors, as you can see here. Now, a more complicated example would be back to this earlier example that we had talked about of finding the actors from Monty Python to The Matrix. So you can see here that this query is actually only slightly more difficult. Just instead of a single pattern, well, we're looking for the same pattern twice, but for 2 different sets of movies. And then you can see here, we've got a shortest path function that goes and finds the shortest path between two sets of patterns, two sets of nodes. Okay. All right. So another reason why I was focusing on Cypher is the current direction for the GQL group is a very Cypher-looking syntax. So you can see here on the right, this is one example that I could find of what they had been working on. And this is a syntax for creating a simple graph, or it looks like the structure of a graph. And you can see here, it looks very much like Cypher in terms of parens for nodes, brackets for relationships. There are some other things that make it different from Cypher, but you can see that Cypher is very much part of its DNA. So if you learn Cypher now, it's kind of a good lead into whatever GQL will eventually be. Okay, so using Cypher, there is an official driver that is created and supported by Neo4j. And when I looked at all the other available graph databases and their query languages, everybody offers a driver, right? You got to have at least a minimum driver. So the Neo4j driver in particular has two unique features. One is using sessions and then having transaction functions. The transaction functions are basically static functions that has the actual Cypher query that you can pass arguments to, and the session handles retries and such. Okay, so the driver does allow you to easily add it to pretty much any general Python project that you might work on, whether it's using other frameworks like Flask or Fast API. I use it in Streamlit a lot, so it's fairly straightforward. But you do need to know Cypher, right? So to help with that, there are several community packages, and this is going to be generally true of all graph databases. There's going to be community tooling. There's going to be third-party services that make things easier. So here I'm showing an example of a query builder. So here you don't have to write a Cypher query and then pass the string into a driver directly, right? You could use a query builder, which allows you to write a query Pythonically, and then it will create the Cypher string for you, and then you put that into the driver. And the one thing I like about this community driver is that it adds in auto completion to Visual Studio Code and maybe IntelliJ as well too. So obviously making development a little bit faster. Now, if you don't want to deal with Cypher at all, you could use a package that includes an object graph mapper and not have to deal with that at all. So one good example here is GQL Alchemy, which was created by MemGraph, which allows you to basically build classes on top of base node and base relationship classes, and then call easier functions to kind of get certain relationships and nodes directly. The GQL Alchemy also interestingly includes a query builder with it, so you get quite a few options if you go a route like this. Next, of course, once you've got information going in and or out of a graph database, connecting a visualization tool goes a long way, and you can use pretty much any of the existing networking and graphing libraries and make them work with the output from a graph database. And the last sort of tool I want to go over is NeoDash or something like this, which is basically a dashboard that you can just run and not even know any Cypher to really just get started, and then just create all these little widgets, and then you can go in and tweak the Cypher or the underlying call, but you can basically create just like business data dashboards from the graph data right into another application of your choice. Okay, so that basically concludes my presentation about basically introducing graph databases to all of you. If you have any questions, if you'd like to reach out to me, you can send an email to me. You can reach out to me on LinkedIn. If Twitter is still running, you can tweet me there. So yeah, just hit me up. I'm always more than happy to answer any questions that you might have. All right. Thank you very much.
Hello. And that was the Jason talk. I hope you really enjoy it. I think it was quite interesting, the approach of it. So with that, we still have some minutes to go for the next talk. So maybe it's the best time for you to grab a cup of coffee, beer, tea, water, whatever, in whatever time zone you are. It's always afternoon in some place in the world, right? So maybe you want to have some other beverage as well. So I will keep you I will put now the video that we have been using for waiting for the talks, and just for as a little spoiler, the next talk, as you saw, it's one of the really important ones, at least in the conference. Not saying that the other are worse or anything, but important because what Martin was saying this morning is that this year Pyjamas opened the opportunity for all the languages talks to be around. And I was lucky enough to be selected for the Spanish one, and now we will have, after some minutes, the Italian one, which is also a really good topic. I mean, you saw already that Jason was talking about GraphQL, and the other one is also about creating some GraphQL APIs, but using other modules. So let's be right back in a couple of minutes, and we see each other. Okay, enough of the song. I am getting tired of the song. Each time we have a break sounding. So yeah, we're just saying that the next talk will be in Italian. It's the first time that there is an Italian talk in Pyjamas. So I really hope that this can motivate you in case your mother tongue is not English. So maybe next year or the next edition, you can maybe submit talk in your own language, which is really cool. So yeah, the one, I mean, Patrick has been working quite a lot with GraphQL and of course Strawberry. If you don't know him, the talk is really nice. I was also trying to watch it before today. So yeah, I really hope that you enjoyed. This is the last recorded talk that we have in this part of the conference. We do have 3 live talks coming up after this one. So stay tuned. We even have like Chris already waiting in the backstage, even if he still needs to wait some more time. But yeah, and also after this talk, I think that I will say my goodbyes until tomorrow, because then we are changing the host. Danny will be joining us shortly as well to follow with the live talks. So yeah, just that. I mean, maybe you saw during this couple of minutes in the break, we have this raffle that you can participate for. That link is now there on the screen. Quite simple, bit.ly, and then Pyjamas 2022 raffle. And also we have this really nice moving banner in case you want to join the Discord community, you want to check the code of conduct that of course we have in the conference, or maybe if you're just tuning in, you're curious about the schedule, just drop by pyjamas.live and you will have all the information there. So without further ado, I would like now to leave you with the Italian talk from Patrick. It's in Italian. Sadly, we couldn't figure out the subtitles, but don't worry, the slides are clear enough so we can follow it, and we can maybe learn a few things about Italian. So I hope you liked the talk. I will try now to share the talk, and here we have it.
Ciao a tutti, mio nome è Patrick, sono un developer advocate da Apollo GraphQL. Noi creiamo tool per rendere la vita facile nell'utilizzo di API GraphQL e nella creazione di API GraphQL. Oggi vedremo come possiamo creare un'API GraphQL utilizzando Apollo Federation e Strawberry GraphQL. Strawberry GraphQL è una libreria Python che ho creato qualche anno fa, che permette di creare API GraphQL usando Python in modo, diciamo, molto semplice, utilizzando una sintassi che è molto pythonica e utilizzando una feature relativamente nuova di Python che sono i typings, quindi la possibilità di definire i tipi per ogni oggetto in Python. Ok, prima di vedere un po' cos'è Apollo Federation, perché dovremmo usarlo, voglio fare un piccolo recap su cos'è GraphQL. È comunque una tecnologia abbastanza nuova e specialmente in Python non c'è molto utilizzo, almeno diciamo in comparazione con REST, che è, diciamo, un po' l'alternativa. Ok, qui stiamo praticamente parlando di API per applicativi web. Quindi praticamente GraphQL è un tool che ti permette di creare API per delle applicazioni. Per esempio, quando facciamo REST avremo delle API dove c'è un endpoint per ogni risorsa, quindi per esempio se voglio prendere un utente da un'API devo fare una chiamata a /user/id, mentre su GraphQL gli endpoint non esistono più, ce n'è solo uno, e invece di appunto usare questi endpoint per definire cosa voglio ricevere, mando un documento tipo questo. In questo caso sto dicendo, voglio prendere un utente con id uguale a 1 e per questo utente voglio prendere il nome. E quando il server riceve questa richiesta, fa il parsing, la valida e poi cerca di prendere i dati dalle sorgenti dati. In questo caso appunto ritorna esattamente quello che abbiamo richiesto, quindi l'utente con il nome e basta. E questa è una delle potenze di GraphQL. Tra poco vedremo un esempio leggermente un po' più complesso e capiremo perché è una valida alternativa a REST. come funziona? Praticamente noi abbiamo un client che fa una chiamata di solito post, può essere anche get, a un endpoint che è appunto di solito /GraphQL e manda un documento tipo appunto quello che abbiamo visto prima. L'API GraphQL lo riceve, lo valida e poi va a prendere i dati da database o quello che è. Una cosa importante da notare è che GraphQL non ha nessun requisito su dove i dati esistono, funziona con qualsiasi cosa. Come vedremo dopo sono praticamente delle funzioni Python che ritornano questi dati, quindi i dati possono essere su un DB, possono essere anche in un'altra API, possono essere in memoria, eccetera. Poi una volta che appunto il server ha fatto il suo lavoro, il client riceve esattamente i dati che abbiamo richiesto. Andiamo a vedere un esempio di come funziona GraphQL. Allora, io ho creato un'API simile a quella che abbiamo visto qui. Questo tool si chiama Apple Explorer, permette di testare velocemente delle API GraphQL usando questa interfaccia che è quasi come fosse VS Code in un certo senso. La cosa carina è che ti permette anche di fare l'autocomplete, quindi per esempio adesso voglio prendere l'utente, per l'utente voglio prendere il nome e poi devo passare un ID. Questa sintassi qui è la sintassi estesa di GraphQL, stiamo dicendo che voglio fare una query, quindi un tipo di operazione di tipo query, ho queste variabili, quindi user ID di tipo ID, e poi questo user ID viene passato giù qui con questo, diciamo, placeholder, e poi posso usare un JSON per passare le variabili separatamente dalla query. Ok, quando eseguo questa operazione il server mi ritorna esattamente ciò che ho richiesto. Se provo per esempio a chiedere l'età, eseguo questa operazione, mi viene ritornato anche quello. E questo funziona per tutti i campi che esistono su questo utente. Quindi per esempio posso anche prendere gli articoli e non mi devo preoccupare di nessun endpoint diverso, praticamente tutto viene eseguito per me. Ora vedremo un po' come funziona proprio diciamo dietro le quinte, diciamo così. In pratica ogni API GraphQL ha uno schema e questo schema definisce tutto ciò che è disponibile nelle API, quindi tutti i campi, tutti i tipi che possiamo ottenere. Quindi in questo caso un'API simile a quella che abbiamo visto ora, un po' più semplificata magari, è come questa. Quindi abbiamo un tipo utente che ha un ID, che è di tipo ID, e questo punto esclamativo significa che questo ID è sempre presente, quindi non sarà mai nullo. Il nome è tipo stringa, sempre presente, e l'età è tipo intera, sempre presente. E poi abbiamo un tipo, diciamo, speciale, che è il tipo query, dove c'è un singolo campo user che accetta un argomento ID obbligatorio e ritorna uno user che non è però obbligatorio, perché se tipo non esiste un utente con quell'ID ritornerà nullo. E poi, come possiamo vedere, se faccio questa query, il campo user va dal tipo query, il campo nome va dal tipo user, perché il campo user ritorna un tipo user. Come dicevo, questo tipo qui è speciale perché prende il nome query è importante in GraphQL perché stiamo dicendo che tutte le query, quindi tutte le operazioni di lettura, tutti i campi che cerchiamo di prendere da quello, diciamo, dal root, dalla radice, vengono da questo tipo query. Infatti spesso viene chiamato anche come root type. Quindi come possiamo vedere questo campo di, diciamo, primo livello, la sorgente è la query. Infatti se vediamo qui, andiamo a leggere la documentazione qui a sinistra, possiamo vedere che ci sono dei root type e query è il nostro root type ed è quello che stiamo usando in questo momento. Esistono anche altri root type che sono mutation e subscription. Mutation viene usata per fare qualsiasi cosa che ha dei side effect, quindi creare un utente, cancellarne uno e così via. Subscription è per diciamo, registrarsi degli eventi e ricevere aggiornamenti in tempo reale su quell'evento. Ok. La cosa bella di GraphQL è che essendo tutto tipizzato, noi possiamo sapere quando facciamo una richiesta possiamo solo sapere cosa viene ritornato. Per esempio in questo editor qui, anche facendo l'over sulle varie cose, ti dice cosa viene ritornato, e se provo a cercare di chiamare un campo che non esiste, ho già un errore qui, e se provo a eseguire questa query ci sarà un periodo di uno step di validazione che apparentemente blocca tutte le query che non sono valide. E stessa cosa se proviamo a passare a un parametro sbagliato oppure un tipo sbagliato. È molto, molto figa questa cosa. E questo potrebbe essere un po' simile a OpenAPI per API REST, però la differenza tra GraphQL e REST è che lo schema è la base di GraphQL, senza lo schema non funzionerebbe. Ed è molto figo perché appunto avendo questa solida fondazione sotto, praticamente ci sono un sacco di tool che sono nati che fanno uso dello schema per semplificare la vita degli sviluppatori. E uno di questi tool è Apollo Federation. Nelle API che abbiamo fatto vedere, abbiamo visto prima, praticamente noi stiamo appunto facendo la query a un singolo monolita, però se vogliamo aggiungere dei microservizi aggiuntivi diventa un po' complicato con GraphQL, perché mentre sul REST questa cosa diventa facile, quindi per esempio abbiamo un gateway che ha 2 API, e per esempio vogliamo fare che ogni volta che prendiamo i dati dell'utente usiamo un API, quando prendiamo l'API e i dati del blog usiamo un'altra API o un altro microservizio. Il resto possiamo usare URL. In GraphQL questa cosa non è più fattibile, almeno non è così facile. E praticamente GraphQL Apollo Federation è nato proprio per risolvere questo problema di GraphQL. Non esiste un modo semplice per combinare più API in una. Praticamente diciamo che il nostro obiettivo è replicare quelle API che vi ho fatto vedere prima, dove prendiamo un utente e poi per l'utente possiamo anche prendere gli articoli che sono stati scritti. E praticamente noi avremmo idealmente uno schema tipo questo, quindi c'è il tipo utente che ha i campi che avevamo prima, però anche un campo per gli articoli che però viene dall'API del blog, e poi c'è un tipo articolo che comunque viene anche dall'API del blog, e poi nella query abbiamo 2 campi, user e articolo. User dovrebbe venire dall'API del user e articolo dovrebbe venire dall'API del blog. Un modo per fare questo è appunto usando Apollo Federation e creando 2 API GraphQL, quindi ce n'è una per gli utenti e una per il blog, e dividiamo queste API appunto in base ai dati che ci sono. Quindi per esempio per gli utenti abbiamo l'API che avevamo visto prima, prende un tipo utente con id, nome e età, e poi un tipo query con l'unico campo che è quello dello user. Poi per il blog abbiamo un tipo articolo, abbiamo un tipo utente e un tipo query. Una cosa da notare qui è che questo tipo è praticamente molto simile al tipo qui, però ha solo le informazioni che sono necessarie per questo servizio. Come possiamo vedere, l'unica cosa che ci serve sapere nel microservizio del blog è l'id dell'utente, e poi la lista degli articoli siamo noi a ritornarla basata sull'id dell'utente. Ok. In teoria, praticamente questi 2 pezzi sono ciò che ci permettono di combinare le nostre API usando Apollo Federation. Però c'è un pezzo mancante. Mentre Apollo Federation non fa non ha nessun preconcetto di come funzionano le API, e quindi ha bisogno che noi definiamo delle entità che sono praticamente dei tipi GraphQL che possono essere estesi e condivisi tra i vari servizi. In questo caso noi abbiamo un tipo utente che è definito appunto sia nell'API degli utenti sia nel blog. Questo è un ottimo candidato per diventare un'entità, perché prende quello che stiamo definendo è che abbiamo una base qui a sinistra negli utenti e poi abbiamo un'estensione qui nell'API del blog. Per fare tutto ciò, per definire questo tipo come un'entità possiamo usare una direttiva. Questo è una feature di GraphQL che ti permette di aggiungere come se fossero delle annotazioni di tipi, campi, eccetera. In questo caso stiamo dicendo, vedi, questo tipo utente ha una chiave dove il campo ID, come se fosse una chiave primaria su un database. E facciamo la stessa cosa sull'API del blog. Probabilmente poi Apollo Federation, usando il router o il gateway, si occupa di combinare queste due API in una singola API. Quindi probabilmente, appunto, facendo la combinazione di queste due API abbiamo esattamente le API che volevamo avere. Ok, vediamo un attimo queste cose in pratica. Noi, probabilmente, l'API che abbiamo usato prima, questa qui, in realtà già sta usando Apollo Federation. Se noi andiamo a vedere qui in Explorer, abbiamo la possibilità di vedere i subgraph, che sarebbero le singole parti di questo grafo. Quindi c'è un'API per il blog e un'API per gli user. In schema qui possiamo vedere SDL, che sarebbe la definizione della nostra API. Questa è l'API completa, come possiamo vedere esattamente quello che ci stavamo aspettando prima. Quindi c'è tipo articolo, il tipo user, e poi c'è la query con articolo e user, e lo user anche gli articoli. Una cosa interessante è che questa è la composizione di questi due subgraph. Quindi se noi andiamo a vedere user, per esempio, vediamo che c'è il tipo user con la chiave che abbiamo definito prima, id, nome e età, però non c'è il campo degli articoli. Il campo degli articoli è definito qui, quindi abbiamo questo tipo user di nuovo, dove c'è solo l'id e il campo per gli articoli. Queste cose qui, schema, link, entities e service, sono dei campi che sono definiti per Apollo Federation, però sono dei campi di cui non abbiamo bisogno di, diciamo, preoccuparci. Per esempio, usando Strawberry o altre librerie che supportano Apollo Federation sono creati automaticamente e servono per Apollo Federation per funzionare. Magari, se abbiamo tempo, farò vedere un esempio di come sono usate. Ok, adesso ritorniamo qui. Allora, se io faccio questa API, questa chiamata all'API, qui quindi prendo solo, diciamo, un utente, prendo solo il nome e l'età. Conoscendo l'API sappiamo che questi dati vengono dal servizio degli utenti, quindi possiamo vedere qui con la query plan, possiamo vedere che stiamo facendo praticamente una singola fetch agli utenti, quindi il nostro router, ciò che sta in fronte alle nostre API, sta solo contattando le API degli utenti. Appena aggiungiamo gli articoli, quindi prendiamo per esempio l'id dell'articolo, possiamo vedere che ci sono più chiamate adesso. C'è una fetch user, quindi prendiamo il singolo utente che abbiamo richiesto, e poi andiamo in blog e prendiamo tutti gli articoli per questo utente. E poi c'è un'operazione di diciamo, merge di tutti i dati. Quindi seguendo queste API possiamo vedere che appunto ci sono tutti questi dati che però sono combinati tra più servizi. L'altra cosa molto interessante è che praticamente questo router, il query plan che fa non è un query plan banale, ma è ottimizzato in base a ciò che viene richiesto. Se io provo qui a prendere un singolo articolo con uno slug, magari tipo blog, e prendo il titolo, possiamo vedere che qui le operazioni non sono più sequenziali, ma ci sono delle operazioni in parallelo. Prende questa operazione qui è fatta allo stesso tempo di questa operazione. Questo ovviamente per ottimizzare, diciamo, i tempi in cui questi dati vengono presi, ma anche perché questa operazione qui e quest'altra operazione non hanno dipendenza tra di loro, quindi possono essere eseguite in parallelo. Quindi poi se le eseguo posso vedere esattamente i dati che ho richiesto. Ok, spero sia stato chiaro. Adesso vediamo un attimo come implementare questa API usando Python e Strawberry. Allora, finora noi abbiamo visto qualcosa di questo tipo, che prende lo Schema Definition Language, o chiamato comunemente SDL. In GraphQL ci sono due modi per creare API. La prima è prende l'SDL, quindi noi definiamo il nostro schema e lo scriviamo proprio a mano, così come è scritto qui, e poi usiamo delle librerie per associare ogni campo con delle funzioni Python, in questo caso, che sono chiamate resolver. E questo qui è un'operazione che si chiama, o un modo di sviluppo che si chiama schema first, dove noi appunto scriviamo prima lo schema e poi lo associamo al codice. Il problema di questo approccio, o problema meno per me, è che noi stiamo scrivendo un sacco di codice, un sacco di tipi, che però non siamo più in grado di riutilizzare in Python. In Python da un po' di tempo c'è la possibilità di poter aggiungere dei tipi a parametri e variabili, tipi di ritorno, eccetera. Quindi, per esempio, in questo caso io sto dicendo che questo getUser accetta un ID di tipo ID e ritorna o user oppure none. Il problema è che questo user qui noi l'abbiamo definito in GraphQL con l'SDL, però non l'abbiamo definito in Python, quindi dovremmo avere un'altra classe qui dicendo, vedi, questa è una class user che ha questi campi, eccetera, che è un po' non il massimo, perché appunto non stiamo usando i vantaggi di Python, che è la possibilità di scriverlo direttamente. E per questo motivo io preferisco utilizzare un approccio che è code first, dove scrivi codice e poi dal codice generi l'SDL. La cosa bella di Python è che la sintassi per definire tipi è molto simile a GraphQL, quindi diciamo che non è molto diverso, oltre che questo è molto facile convertirlo in Python. Infatti, come vediamo qui, per esempio, il tipo utente, possiamo vedere che abbiamo una classe utente dove c'è un ID, un nome, un age, e questa sintassi qui con i due punti ci permette di definire il tipo di questa proprietà. Poi la parte, diciamo, magica, tra virgolette, è tutta fatta con questo decorator, che converte questo tipo in un tipo GraphQL e anche aggiunge delle utilità, tipo il costruttore e altri metodi. Poi per aggiungere i resolver, possiamo usare quest'altra funzione che è strawberry.field, dove passi un resolver, che è una funzione Python, e poi strawberry va a leggere tutti gli argomenti definiti sulla funzione e li passa allo schema. Quindi una volta definito questo qui, avremo uno schema che è esattamente quello che ci aspettiamo qui. Quindi questi due sono equivalenti, solo che qui stiamo definendo tutto in Python e non abbiamo bisogno di duplicare nessun codice. E poi utilizzando tool come MyPy, PyWrite, ogni volta che utilizziamo questi tipi abbiamo una maggiore confidenza sul nostro codice, perché sappiamo che, per esempio, se io metto age, metto 123 come stringa, avrò un errore qui, che è molto comodo, ha risolto un sacco di piccoli bug che capitano spesso. Ok. Ora, noi abbiamo visto un po' appunto come creare queste API con Python, Strawberry. Letteralmente è tutto qui. Questa è un'API funzionante. L'unica cosa è che questa API non è un'API che funziona per Apollo Federation, perché, come dicevo per Apollo Federation abbiamo bisogno di queste direttive. E queste direttive sono molto semplici da definire nello SDL, perché appunto sono una parte della loro sintassi. In Strawberry c'è presente un metodo, un parametro del tipo dei campi, eccetera, dove possiamo passare una lista di direttive, per esempio così. Quindi qui, per esempio, dovremmo passare una direttiva chiamata key con un fields che è uguale a id. Però questa cosa è un po' scomoda, perché noi comunque stiamo usando codice Python e comunque Apollo Federation, utilizzare le chiavi è una cosa molto comune, quindi abbiamo creato una versione semplificata di quello che ho appena fatto vedere, con il decoratore chiamato strawberry.federation.type, che accetta un parametro keys, quindi prende questo e ti permette di fare la stessa cosa che abbiamo definito qui, una sintassi abbastanza leggera e spero semplice da capire anche. Poi l'ultima cosa che dobbiamo fare è praticamente modificare questo schema e farlo diventare uno schema che funziona con Apollo Federation. Come vi ho fatto vedere, ci sono dei campi aggiuntivi e dei tipi aggiuntivi che vengono creati automaticamente da Strawberry per poter far funzionare Federation. E tutto ciò è fatto con queste 3 linee, quindi invece di fare strawberry.schema abbiamo strawberry.federation.schema e poi dobbiamo abilitare Federation 2, che è la versione nuova di Apollo Federation che semplifica un po' di cose e probabilmente sarà il default tra penso qualche mese. Ok, allora adesso voglio farvi vedere un po' il codice proprio di questa cosa e magari vi faccio vedere anche come funziona Federation, diciamo un po' dietro le quinte. Qui abbiamo questa è l'API che appunto stavamo usando prima, è fatta con FastAPI e Strawberry. Praticamente non c'è nulla di speciale qui, praticamente questo è un po' come se fosse un boilerplate di FastAPI. L'unica cosa interessante magari è il course per far funzionare l'Explorer su Apollo Studio. Però oltre questo non c'è nulla di particolare. Praticamente usiamo il router di FastAPI di Strawberry e poi usiamo lo schema che abbiamo definito qui. Lo schema appunto è veramente semplice, quindi c'è uno schema dove passiamo la query, che è da dove arrivano tutti i dati. Poi la query ha un singolo campo chiamato user, che ritorna user o none. E poi vabbè, in questo caso stiamo ritornando sempre un utente, con l'id che passiamo, giusto per semplificare un po' il test. Però qui, per esempio, è dove faresti una chiamata a un database o un'altra API, per esempio. E poi il tipo utente prende i vari campi e poi ha la chiave per Apollo Federation. Ok, poi l'altra API, quella del blog, è praticamente uguale, è il boilerplate per FastAPI è qui, e poi c'è lo schema che ha qualche tipo in più, ma nulla di troppo complicato. Quindi c'è lo schema di nuovo, c'è la query dove ritorniamo un articolo con un determinato slug, in questo caso. Poi il tipo articolo è banalmente un tipo SQL. E poi dove la parte più interessante è questa qui. Qui stiamo definendo l'utente, dove abbiamo l'id, che è questa chiave, quindi il modo in cui riusciamo a prendere i dati per questo utente. E poi abbiamo un campo chiamato articles, che ritorna una lista di articoli, dove usa questo resolver che prende gli articoli per un determinato utente. Root è un nome speciale in Strawberry al momento, che ogni volta che tu passi root gli viene ritornato il parent di questo campo. Per esempio, appunto, il campo è articles e il parent sarà user. Quindi noi qui saremo in grado di avere, per esempio, qui stiamo utilizzando author come root. Sì, praticamente è tutto qui. Una volta che abbiamo queste cose, diciamo, online, deploy, possiamo andare a usare Apollo Federation per combinarle insieme. Ci sono dei modi per farlo anche locale, però volevo farvi vedere un po' questa piattaforma giusto perché è abbastanza semplice avere tutto online. Quindi appunto io ho fatto il deploy su questi 2 URL e poi li ho caricati qui usando questi comandi qui che sono abbastanza veloci da definire. Quello che succede quando si aggiunge un subgraph, c'è uno step di validazione di Apollo per far sì che l'API funziona sempre, anche se noi carichiamo qualcosa che non va bene, che prende come se fosse una CI che ti stoppa nel fare cose strane. Poi ci sono anche altre cose tipo il changelog che ti dice vedi, hai aggiunto un nuovo campo, eccetera, che sono molto comodi quando lavori con API grandi. Ok, una cosa che volevo farvi vedere adesso era praticamente questo query plan qui e come funziona questa parte qui. giusto per capire un po' cosa succede. Praticamente quando eseguo questa API, questa operazione, sto chiedendo un utente dal servizio di utenti e poi sto chiedendo gli articoli per quell'utente dal servizio del blog. E quando vediamo il query plan come testo, vediamo più o meno cosa sta succedendo come chiamate GraphQL. Quindi per esempio c'è una prima chiamata così al servizio utenti e ci sono due cose particolari, una è type name e l'altra ID. E qui non abbiamo richiesto l'ID dell'utente, non abbiamo richiesto il type name. Il type name è semplicemente il tipo di questo campo, che sarà user in questo caso, e l'ID è la chiave di questa entità. Questa chiave e questo type name poi vengono passati al servizio del blog per poi poter prendere gli articoli. Non è forse troppo chiaro da vedere, quindi magari facciamo un esempio qui. In pratica questo è il mio servizio dove ci sono gli articoli, quindi qui posso prendere un articolo con slag 1 per esempio e poi posso prendere il titolo. Però per esempio qui io non ho nessuna possibilità di prendere un utente, quindi se volessi prendere gli articoli per uno specifico utente ho bisogno di usare questa entità, questo campo speciale creato da Strawberry per Apollo Federation che si chiama Entities, che accetta una lista di rappresentazioni. Queste rappresentazioni sono praticamente il tipo e la chiave del tipo. Quindi avremo type name e poi avremo che è user e poi avremo l'id, per esempio 1 in questo caso. E prende questa API qui, questo campo qui, ritorna una union. Quindi per questo motivo quando provo a fare autocomplete mi dà solo type name, perché prende quando queste API potrebbe ritornare vari tipi in base a cosa passiamo. Quindi prende per discriminare, prende pattern matching sul tipo. Abbiamo bisogno di usare questa sintassi che è ... on e poi il tipo. Quindi quando sappiamo che stiamo prendendo uno user possiamo prendere l'id, in questo caso 1, oppure possiamo prendere la lista degli articoli. Così. Questo è esattamente quello che sta succedendo qui. Quindi facciamo questa query e poi diciamo il router, quindi Apollo Federation, crea un query plan dove cerca di ottimizzare e prendere i dati dai posti diciamo più consoni. Ok, spero sia tutto abbastanza chiaro, era un po' di concetti, un po' di cose da vedere, però se avete domande, siete interessati a usare GraphQL, specialmente in Python, potete entrare su Discord oppure contattate su GitHub oppure via email o su Twitter, comunque un po' di contatti qui. Sono assolutamente felice di rispondere a tutte le domande. E, appunto, ci becchiamo online. Grazie.
Okay. I'm not muted. Yes. That was Patrick Talk. Is a really nice topic. I remember, I think at the first time that I saw Patrick Talk was in a Python Pizza conference here in Berlin. So we do have the next host here on the backstage. So I will allow her to enter. Hey, Danny.
Hey, Christian.
Nice to meet you and see you and
Can you
everything.
hear me,
I am a
Christian?
zombie. Sorry. What?
Can you hear me, Christian?
Yes. We can
Okay,
hear you.
because I'm
Well,
just
and
testing
I'm about to
my
make
mic.
sure. Are you here as an admin?
Yeah,
Or is it
now
a-
as an admin.
Okay.
Yeah.
Perfect. So you can see that our speaker is already waiting and ready with, I think that he even has some merch from the conference. By the way, you also need to get some merch, but okay, cool. So that's it from me. Now I will go to have a couple of hours sleep and we'll see you tomorrow. I will leave it up to Danny. And first, maybe I will add the next speaker to the... Hey, Kuram, you are now in the transmission. I leave you in good hands with Danny. Good luck with your talk.
Hey,
And
nice to meet
see you later.
See you. Take care, Christian. Thank you.
Thank you.
Hey. Hey everyone, my name is Danny Perez, as Christian just told you, and we continue with the 24 consecutive hours of Python talks about Python and Pyjamas Con. And now we continue with a talk from, okay, I'm gonna try to say your name. Just you need only correct me if I'm wrong. The next talk is from Kuram Saham.
Very
Yes,
good.
it's
Yeah,
okay.
Karam Zaman.
Yeah, he will be talking about the introduction to exploratory data and analysis with Google Colab. And hey, interesting topic. How are you doing here? Going
Good. I'm
great?
recovering from COVID a little bit, but really glad to be here. Excited this is online. Got my pajamas merch. If you haven't got it yet, it's a very comfortable hoodie. Strongly recommended. My kids love it. So I would, if you haven't already got yourself some merch, go check it out. Ready whenever you are, Danny.
No. For me, unfortunately, didn't arrive on time,
Oh no.
but I will be still waiting for my pajamas. And from which time zone are you?
I'm in Washington D.C., so I'm in the Eastern Standard Time.
Okay, still early.
Mhm. Yeah.
Okay, but go ahead. I will let you the whole scenario for you, and yeah, can you share your screen? Let me. Okay. Yes, you're ready. Sure.
Awesome. All
Yeah,
right.
I leave you.
Thank you so much. So we're
See you in some minutes.
okay. Thank you so much. Okay, so tonight's talk is going to be Introduction to Exploratory Data Analysis with Google Colab. And so we'll talk about what is EDA, why is it important, what is Google Colab, and I'm going to share a link. I'll share it with the moderators, and basically they can hopefully share it to everybody else. And the idea here is you can try to follow along and try to play around with the data as well as the Google Colab notebook. So we're going to talk, like I said, a little bit about EDA and GCL. We'll give like a little technical overview of this notebook, and then we'll open up the notebook and sort of dive right in and start learning about EDA by seeing real examples of how it's done. Okay, a little bit about myself, nothing important. So you have a company called Fifth Tribe. I'm an adjunct professor at Georgetown University. I'm an amateur Pythonista. I kind of use Python to study extremism online. Did some projects on Kaggle here and there, won a few hackathons and stuff like that. But I'm not like a software developer who does Python all the time. This is more sort of something I do more in my free time and sort of as a hobby. And these are my social media links and my email if you want to keep in touch after the talk is over. It's Khurram@fifthtribe.com. And my Twitter is Zaman Digital, and my post.news is Khurram Zaman if you're on that. So the goal here is really just to inspire folks to take on a topic and make it accessible and to be comfortable, learning. And so to do this workshop, you're going to need a laptop, internet, obviously. You're going to need a Gmail account and your thinking caps. So what is exploratory data analysis? There's a really good article by Andy McDonald. It's called Data Quality Considerations for Machine Learning Models. And I think it's one of the best articles on EDA that's on Medium and probably online that really explains thoroughly what it is and very systematically with definitions and so on and so forth. So if you want to take a look at that, hopefully they'll share the presentation afterwards and you can and check out the links that are in here. The primary thing that we want to do with EDA is, sometimes we're looking at basic data analysis, or we're trying to get our data ready for a machine learning model. And then we want to do that. We have good, clean data that's it's well organized. It doesn't have issues with it. And the purpose of EDA, of exploratory data analysis, is to take an initial look at at your data and identify issues early on. It's kind of the way I would think about it is almost like if you get something from IKEA, like a furniture set, and you open up the box and you've got the instructions, and then they got pictures of all the different things, and you just want to look and make sure all the pieces that you have are matching what's kind of in the instruction guide. And that's kind of what I think EDA is. You want to make sure that you understand what are all the parts. You want to see if anything's missing. Sometimes you'll see you have extra things. That might be a good thing, might be a bad thing. And so that's really what EDA is doing, is before we do anything really big with our data, we want to just kind of take a look and just just kind of see what's there and what the structure of the stuff is. And we also start generating insights pretty early on just by looking at the data with EDA. So some very simple and common EDA inquiries, if you want to just break it down, is we want to first understand is how much data is there Is there a lot of data? Is there a little bit of data? That influences what types of things you can do on that data. If it's too large, you might have trouble running some functions on it or running some processes on it. You might not even be able to see the data properly, visualized if you're in a notebook. If it's too much data, you want to get a sense of the shape of the data. Is it really have a lot of rows? Does it have a lot of columns? Is there any data missing is the second kind of inquiry that we have. And if the data is missing, what are you going to do about it? Are you going to try to fill in that data? And if you're going to fill in that data, how are you going to fill it? So if that data is numerical, you can treat it a certain way. If it's categorical, you treat it another way. If you're not going to fill in the data, are there going to be any consequences down the line? So maybe you're trying to run some other sort of, sort of visualization, and maybe it's not going to work if the data is missing. So those are things you got to think about: is there any data missing? You want to make sure that you answer that question. The third thing is the data accurate. One common thing that you'll see is that does the column type match the actual data? So it might look like numbers when you look at it, but if you actually check the column data type, it might actually be an object or something. And so you might need to fix that. Last but not least is the data duplicated. If the data isn't unique, do you want to keep it? Do you want to get rid of it? Those are all sort of questions that you want to think about. There's a ton more, but these are kind of, this is an introductory level. This is kind of the 4 main things that we want to think about when we're doing our EDA. Okay, what is Google Colab and why use it? So Google Colab, I've recently took a few different online program with MIT called Applied Data Science Program. A lot of it was initially in Jupyter Notebooks, and I used it for quite a bit. And then in the middle of it, we ended up switching to Google Colab, and I really, really liked it for a couple of reasons. And so one is that with Google Colab, there's no software installation necessary on your computer. It's got GPUs, TPUs, it integrates with Google Drive, it runs in the cloud, it's great for collaboration. And it's got some nifty little tiny features that are just small, tiny add-ons that make it just a little bit more delightful to use. And pretty much anything that you can do with Jupyter Notebooks, you can also do with Google Colab. The biggest downside with Google Colab, one reason not to use it, is that it requires internet. And as far as I'm aware of, there's not really a way to use it offline quite yet. And so that's if you're like in an airplane or you have limited Wi-Fi out in a remote work area, this might not be the best option for you, and you might want to go back to using sort of a Jupyter notebook. All right. So here's a quick technical overview of this notebook and what we're going to be doing with it. We're going to look at 1,000 tweets, or actually it's about 100 tweets regarding the topic of interfaith. And the first thing we're going to do is we're going to set up our Google Colab account. It's pretty easy, but it's basically 2 or 3 steps. We're going to install some libraries. And so the main one we're going to be using is Pandas, but the notebook has Matplotlib, Seaborn, NLTK, Spacey, a few other ones that are there for NLP stuff. You can ignore those. The main one is going to be Pandas. The third thing that we're going to do is we're going to connect to our Google Drive. We're going to open up a spreadsheet that's in there, and we're going to read that CSV of tweets, put it into a data frame, and then we're going to do some analysis of the tweets, the hashtags, visualize it, ideally come up with some observations, and then the last thing we're going to try to do is come up with some recommendations here. All right. So let's go ahead and get started. So this is like a fake brief we have. We've been hired by this interfaith organization. They don't know how to do Twitter. They want to get started, and they got, let's say, 100 tweets with the hashtag interfaith. And our job is just to take a look at these tweets and do some EDA on it and see what insights we can generate and give those recommendations to our leadership. So based off of that, we'll go ahead and dig in. So this is actually a link to the notebook, and I'm going to go ahead and share this in the chat, and hopefully this can go ahead and get shared out as well. And if you get the link to the Google Colab notebook, you'll also get in one of the cells, there's actually a link to the tweets with the CSV. All of this is public, so you can go ahead and copy it and play around with it. But to get started with Google Colab, it's pretty easy. You go to colab.research.google.com. If you're not logged into your Gmail account, then you're going to log in with your Gmail account, and then you're good to go. You just basically create a new notebook, and you can give it a file name. And then there's some basic functionality around, giving, just normal sort of file options. You can edit it, you can view it, you can insert something, you can do runtime tools and help. You can add cells, you can add text. It's very much similar to, like I said, Jupyter Notebooks if you've played around with that. The second thing that we're going to do in Google Colab is go ahead and start installing our libraries. And I'll show you the notebook in just a second. But it's very similar, like I said, to Jupyter Notebook. You're just going to do, if you have to install a Python package, you use pip install. If you've already got the libraries, a lot of them are already kind of built into Google Colab, like Pandas and Seaborn and Matplotlib. You just basically import them and you press the play button and you're good to go. And then we're going to go ahead and connect to Google Drive. And the way that you do that is you're going to mount your Google Drive to your Google Colab. And I'm just going to show this to you. It's much easier to show it in real life. When you mount your Google Drive, what happens is you're going to get a pop-up, and it's going to ask you to choose your Google account. It's going to give you a list of alerts saying, hey, this is what's going to happen if you connect your Google Drive to your Google Colab, and you're just going to hit OK. And then basically, it'll give you the green light to proceed with it. And then we're going to read in the CSV, and then we're going to go ahead and do a bunch of different things. And so these are some of the things that we're going to be taking a look at. We're going to be looking at the shape of the data, so how many rows and columns it has. We're going to be looking into naming column headings. We're going to look at the head of the data, which is the first 5 rows, the tail, which is the last 5 rows, the data types, like what is the data column structure, like is it matching what the data is? We're going to look at use the info function, and then we're going to look at the data itself and clean it up just a little bit. Okay, so a lot of this stuff at the end, bar plots and pie charts, we probably won't have enough time for that, but it's all in the notebook. If you do want to take a look at how to do some NLP and how to visualize some of the findings, that's all in the notebook to do that. Okay, so at this point, I'm just going to go ahead and switch my screen, and here is the actual notebook. Like I said, it's public. I've shared the link with the moderators, and hopefully they can share it out to the rest of you all so you can either follow along and play around with it. But usually when you have a notebook, you want to start with the context, like what's the background of this data set? What is the objective of this data set? I like to also put a data dictionary. So if you have, if the data has a list of column headings, you want to explain what those column headings are. It's not always a given. So this way the next person can kind of come in and they can take a look at it, and they can just really sort of just dive in and not have to guess what they're looking at. So first actual thing we're going to do is we're going to install it as a Python package called Pandas Profiling. It's a little nice package. I'll let you do all my installations up front. It's very classy. You just do pip install -u pandas -profiling, and you're good to go. The only difference between this and Python on your desktop is you got to put a little exclamation mark for it to run, and it runs pretty smoothly. The next thing that we do is we import all of our libraries. The ones that we're going to cover today are really the 2 at the top, which is just Pandas and the Pandas Profiling one. The rest of those are NLP related or visualization related, so I'm not going to talk about those. But here's the first real step that we have. We got, we're going to import and mount our Google Drive. So we use from google.colab import drive, drive.mount, and then we have to put the directory for our Google Drive, and then the pop-up will happen. You'll accept it. You'll go right into it. And now that we've connected our Google Drive, we can point our data frame to read a CSV anywhere in our Google Drive as long as you know what the path is. And so here is the directory path for the specific file that's called tweets underscore hashtag interfaith underscore 08-12-2022.csv. And so you can kind of see that that's a very long directory. One thing that's a little bit annoying with Google Colab compared to, say, Jupyter Notebooks is that, on your desktop, you can pretty easily copy the entire directory path for a file. It's a little bit harder to do with Google Drive. You have to actually manually copy the different folders and stuff like that. I've seen some solutions that try to find a better way, but they require a little bit more of coding to do that, and I just find it easier. Just by the time you just read it, you can and write it down, you can do that. So here's the data frame. We take a look at it, and so we can kind of see that there's something a little strange about it right off the bat. Is that there's the first column, it's got numbers in it. Then there's a second column, and it's got a bunch of numbers in it. And then you have this unnamed, none of the column headings are there. They're filled with numbers, but the first row has the name of the column. So this is a little bit weird. And so just by taking a look at it at the first tab, we're like, well, that's a bit strange. So if we're trying to reference later on using Pandas, the name of the column, it's not going to work. We're going to have to use the position of the column instead of the actual column name. So we want to clean that up a little bit. So let's just take a look at the shape. And the shape, like I said, it mentions the dimensionality of the data frame. This is where you look at the rows and the columns. And so here you can see that there's 100 rows and there's 12 columns. And that's a pretty small data set for our purposes. And so that's good. If you have lots and lots of columns, one thing that's going to happen with Google Colab, it's going to be hard to kind of see everything. One thing that you can do is you can set the max width to how many columns you want to appear And I think you can go up to like 34, maybe even more than that. But that makes it a little bit more easier to use. And so when you see the shape of the column, you're going to notice that if it's really far, in terms of rows versus columns, it makes it harder to manage the data. And so just taking the shape is one of the first things that I like to do, just to get a sense of like, what are we looking at over here? And then we're going to go ahead and look at the columns method, and basically it returns the columns labels of the data frame. And so you can kind of see here, it's a little bit of gibberish. It says 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's not really helpful. And it has an extra column and a row. We're going to clean this up. So the first thing we do is we drop the first column, and we're going to do that by using dataframe.drop, and we're going to identify which column. And it's the first column, which is, we know by the position 0. Axis equals 1 refers to the column, and in place equals true. And then we print the data frame again, and you can see that invisible column that was over here, or not invisible, but visible column that was there, it's no longer present anymore. It's been dropped. So that's good. That's the first step. This is the kind of stuff you do with EDA. You're cleaning up your data, getting it a little bit cleaner and easier to access. And so that's been done. And then we want to take a look a little bit at the data set itself. And so we use .info. And what it's telling us is that the column headings are still messed up. And it's telling us the object type, the data type for all of these columns is object, which is a bit strange. And so what we want to do next is just print out the column names, just take a look at it and say, okay, that's definitely weird. And so what we're going to do is we're going to rename the first the column headings with the first row. And why are we doing that? Because we noticed that the data was there. It's a tweet_ID created. So that not the first row, but the second row had the correct column headings. And so we just want to switch those out. And so what we're doing here is we're renaming the column headings with the first row, and we're dropping basically that first column. And so it's nice and clear. And so when we run the info function again, we can see that its tweet ID is now the column name, created user, tweet source, favorite count, retweet count, geo, which is the country, coordinates, which is the location based on latitude, longitude, language, and entities, which are basically Twitter's way of classifying all the different types of things mentioned in a tweet, such as other people or hashtags or whatever. So that shows us that our data is, we got rid of that extra row, we got rid of the extra column. And now what we're going to do is, one thing that's still a bit odd is when we look at the data types, favorite count, it sounds like a number, retweet count sounds like a number, and tweet ID sounds like a number. So that doesn't sound like it should be an object. It sounds like we want to make those integers or floats or whatever. And so what we do here is we basically use the toNumeric function, and we convert those columns into numeric columns. And then we run info again, and you can kind of see here that tweet ID is now a float. We can see that favorite count is now an int, and retweet count is now an int as well. And so now the data is a little bit easier to use. It's a bit more accurate. So when we're trying to do things like doing value counts, it'll work correctly. Last thing we want to do is to convert the floats into integers. And so that tweet ID, we basically went ahead and cleaned some of that up. And now everything is an integer format. And what we can do here now is we do something called .head of the data frame. And what that does is it gives us the first 5 rows. And so you can see the data is much more cleaned up. We got the tweet ID, created user, tweet, source, favorite count, retweet count, geo coordinates, and language. And we have these entities. And one thing you notice with Google Colab, which is kind of nifty, is they have this button here. I don't know what the name of the button is. I call it the magic button because it looks like a magic wand to me. But when you click on it, it basically converts the cell into this sort of like interactive table, and you can see a lot more of the data that's in there. And so the first tweet that we have here is from 8/13. It's talking about, hey, we're extending a deadline to apply to this fellowship. And that's a retweet of this tweet that's over here, and it's International Youth Day. And so this is the kind of stuff that if you're trying to do EDA and this organization's hired you to see how can they find opportunities for interfaith communities, you're saying, oh, there's a fellowship over here. This is something we found on Twitter, and you guys can, maybe put this share this with our stakeholders and let them know about it. And then to exit this view, you can basically press X and exit out from there. And then this is the tail. We'll press the magic button again, and again, we'll take a look here. And it looks like there is an organization doing an interfaith symposium. There's an interfaith festival in Berlin. And so these are the kind of examples of opportunities that you're finding by scraping Twitter that you can present to leadership and show them what's going on. And then this is the entities column over here. You can see it's got a lot of stuff in it. It's hard to see that data. We'll break that out a little bit later on in using our visualization and NLP stuff. Then we kind of want to take a look at, like, now that we've cleaned up sort of the extraneous headers and rows, we've fixed the data types, we want to kind of see, like, is there data here that we're looking at really unique? And so we can do the account to see the unique values in each column, and then we can drop the duplicates. And so the data that we're looking at is a bit more cleaned up and precise. And then the last two things that we do here in terms of just a quick analysis of the data is we are sorting the values by the retweet count and by the favorite count. So you want to kind of see which tweet was the most popular in terms of retweets and which one was the most popular in terms of favorites. And so again, we press like the magic button, and it's that Berlin Interfaith Festival that seems to be the most popular event. And then there's something, the second most retweeted one is they're looking for interfaith couples for a study. And so again, these are opportunities that you can share with your leadership. And then in terms of favorite counts, this is somebody who tweeted about speaking at the White House, and so on and so forth. There's International Youth Day again. And so again, you're just looking at the data and you're getting some pretty quick insights. So that's kind of a lot of work. And so I mentioned that there was a Pandas profile package that we installed in the beginning. What we do here is you can just install it, you import the necessary library, and then you run it. And what this does is it does a lot of the heavy lifting for you in terms of some of the EDA stuff. It kind of gives you this nice little visualization that's inside of a cell, and it gives you these alerts. And so it says the geo column has a constant value of 0. Basically, the whole thing is like empty. Maybe we should just drop that column. Same thing with coordinates. It's also largely empty. And then you can see that there's no missing cells because we've cleaned up the data pretty well. We dropped the duplicate rows. It shows you the memory, the variable types, numeric versus categorical. And then what it does, which is really helpful, it goes like sort of like column by column, and it gives you an analysis of that data, which I find to be pretty helpful. Sometimes it's not helpful, but a lot of the times it is. And then what it also does is it has these interesting visualizations like correlations. That might not be that useful for this data set because, why would we have the correlation for tweet ID? That's not probably relevant to a lot of the content of the tweets. But you can sort of see here if there's any missing values. And then it gives you, again, sort of the head and the tails. It's all built in. So this is a cool little Python package. It does like a condensed version of EDA. But that's kind of it in a nutshell. I'll show you kind of what the rest of this notebook looks like. This is all NLP stuff. It's using the NLTK library, and it's pulling out sort of the top hashtags, the top mentions, and then it goes into the top words overall. Who are the top organizations mentioned? Who are the top people mentioned? And what are the top apps that were being used? And then the apps is like kind of like a pie chart. And so again, just a little bit of analysis, nothing too crazy. We've already kind of got some opportunities for our leadership. We can write that at the end. In terms of our observations, like what were the most popular tweets, what were the most interesting opportunities, what are some recommendations that we give to the organization. Okay, and I think I'm about 5 minutes left, I believe, and so I'll open up to questions if anybody has any.
Hey. Let me check the chat if we have some questions for Kurama. No questions? Take the chance to do some question for. You can still have 5 minutes. 4.
Okay, cool.
Are you enjoying the conference?
Yeah, it's been really cool. I've been listening in on some of the other talks. Yeah, so I got a question that says, what is the most difficult part in the demo? I think the NLP stuff is like, it's very resource intensive. And so with 100 tweets, it works pretty well. When you start getting into thousands and thousands of tweets, it gets, you need to start doing some like batch processing and breaking up the data into chunks. And that's why using the shape function at the beginning is very useful, because sometimes you look at the data and you might say, oh, this is a small data set. I can do all sorts of analysis on it. But if you start getting it to the point where it's really, really large, you're going to have a hard time, even with Google Colab and even with the Colab Plus account, which I have the most upgraded version. Google Colab in general is free, but if you want to pay for more resources, I forgot how the pricing model goes, but basically I think it's like $7 or $8 a month. It doesn't go up too much, but when you start doing really resource intensive stuff, then the figuring out how to break up the data, I find it to be challenging. And so one use case I have is when I look at extremist content on YouTube or other sort of video platforms. We use I forgot which AWS library it is, but there's a tool they have that does transcription. It's probably like AWS Transcribe or something, I forgot. But what it does is it takes a video and it creates all this text out of it, and it's great. But if you want to go through a couple thousand transcripts, I mean, generates so much text that when I was using Google Colab, I had to figure out how to like break it up into and process it in different ways. So that was, I think, the hardest part is you get it all working and you connect everything, and then you start trying to put in lots of data, and then you get a whole other problem. It's more data, more problems.
Yeah. No. I hope so. Everyone is enjoying this Pyjamas Con 22. And Kuram, thank you so much. It was a great talk. And yeah, for everybody, and these talks will be in YouTube channel for the Pyjamas Conf. You can go and check. And if you want to have more questions for Kuram, go through the Discord. We are in communication in Discord. And thank you. Do you want to say something before?
Just want to say thank you so much. Enjoy the rest of the conference. Bye, everybody.
Bye. Thank you. Hey, we still continue. Still, I think 10 hours left in this conference. And now we have another speaker here. Hi, Chris.
Hello there. How's it going?
I'm doing great. Still living here with my coffee.
Excellent. Yeah, I finished mine off, so I've got nothing left in here, but I've got some water on the side, so just in
Go
case
ahead,
I need it.
take 1 minute. Go.
Oh,
Look for
I'm
more
good.
coffee. Yeah, now you will be speaking.
Exactly. I'll have all the jitters. I'll talk about 5,000 miles an hour, and no one will understand me.
Welcome. Yeah, and now Chris will be working about refactoring. It's a great topic. And we continue here in the first stage as a host. And okay, take coffee and just prepare anything to hear this great topic that will be continuing. Go ahead. I will leave you with your slides. Okay.
All right.
Go ahead.
Well,
And
thank you.
see you in some minutes.
Sounds great. Thank you, Denny. I really appreciate you passing the torch to me, and I'm excited to be here. It's been such a great conference, and I'm sure everybody here has gotten a lot out of this. And I'm excited because I get to talk to you about refactoring, and this is something that I've learned about really just in the last couple of years. It's something that I've actually aspired to learn for like the vast majority of my coding career, but I was always intimidated by it. It was always really smart people who knew far more than I did who would talk about refactoring, and I just felt lost about it. But it turns out there's a lot of misunderstanding about refactoring, and I want to clear it up because being able to confidently refactor your code will multiply your effectiveness and bring you so much more satisfaction in your work. So let's dive in, right? What is refactoring? Refactoring is improving code without changing its behavior. Now, this is a definition that most people don't seem to know, at least in my experience, because on the teams that I've been a part of, when they've talked about refactoring, they've meant that, well, somebody needs to fix something. And that's not quite refactoring. You see, usually what happened was on the projects I've been on, project management have decided that there's something wrong with the code base and they need to take a developer away from creating new functionality to do something new, whether it's clean up code, reduce technical debt, or introduce a new dependency, or in other words, fix something, right? And so someone would go off, usually one, maybe 2 or 3 developers would go off and like kind of fix the code, and then we'd have like all this pain in bringing their code back into the main line where we were all working, right? It was painful, and that's not refactoring. I mean, you can call it reducing technical debt, you can call it cleaning up code, but it's not refactoring. Refactoring is a tool that improves the design of your code and how it communicates. So that's what refactoring is. Let's describe why we refactor. We refactor to make our code more understandable and to support new directions. These are the 2 primary reasons why we do that. So let's look into this a little bit more. When Guido van Rossum was creating Python, he had a number of guiding principles, one of which was code is read far more than is written. And this is such a great insight, because we need to write our code in a way that drives understanding of what it does, right? Let's, for example, look at a piece of code. Now, this is an API endpoint that calculates the price of a lift ticket for a ski lodge. And looking at this code, I'm reminded that computers will execute code no matter how confusing it is to humans, right? So we need to write code that explains the reason why our code does what it does. We need to write our code in such a way that somebody new to the code base should understand not only what the code does, but how many variations there are in its behavior, and how that variation varies, right? So you've had a little bit to look at this code. Let me scroll down so you can see the rest of it. I want you to think about this. Like, how would you feel if you had to maintain this code? Do you feel like you understand this code and what it would cost? If you needed to add a new lift ticket, how would you do that? Let's compare that to a refactored code that does exactly the same thing, right? This is much more clear that there are really only 2 types of tickets, right? And the primary way that it varies is on the age of the person asking for the ticket. Now, I want to say the code on the left is not bad code, right? I mean, I've written code like this. This is code that actually works, so it's not bad code. But the code on the right is so much more readable and understandable, and that's what we want to achieve. One of the things we want to achieve when we refactor. I should also pause. At any point, ask questions in the chat. I'll have some extra time at the end of the talk, so we'll be able I'll be able to answer them. So that's one reason why we refactor code. The second one is to support new directions. Distinguished computer science professor Terry Winograd once wrote, "The main activity of programming is not the origination of new independent programs, but the integration, modification, and explanation of existing ones." So he's an academic, and it's a little hard to understand exactly what he means, right? But essentially what he's saying is, anytime we program, the vast majority of the time that we program, we are not writing new code. We are modifying what's already there. We are explaining what's there to others, whether through documentation or meetings, or we're trying to integrate things together, right? He goes on to say that it's extremely difficult. Whoa, whoops, gave away one of my, sorry. Oh no, it's extremely difficult to modify existing programs. The cost of which is almost never measured, but in at least one case, it exceeded the original development cost by a factor of 100. That's staggering, right? It is expensive. It can be expensive to maintain code. And why is that? I think it's because one of the main reasons why is because we are under pressure to deliver new features all the time, right? And when we come to our code with a new feature, we look for code that is closely related to what we want it to do. And we kind of just add more code in that space to support what we want, right? And if we don't stop and think about the design of our project, the overall design and how to improve it, we end up increasing technical debt. It just add more and more as we go along. And it really makes it painful, right? And it gets to the point where, as I said before, somebody needs to go in and fix it. And we need to go through that pain to get our code back to some place where we can use it again, right? But thankfully, unlike these bricklayers, it is much more easy for us to update code that's already working so that brittle and stagnant code can become pliable and meet new requirements. And that is why we refactor. Now, question is, when should we refactor? I think there are two primary times we should refactor. One is before we add new functionality. And Kent Beck once said that for each desired change, make the change easy. Warning, this may be hard. Then make the easy change. So when you have a new requirement, this is like such the perfect time to refactor, because you have something that says your code needs a change and there's a specific way that you should change it. And that's essentially what refactoring can do, right? You can look at your code and say, if we knew we were going to need to do this in the past, how would we have written our code? And then you can rewrite your code to do that. Next, you should refactor after achieving something. So the test-driven development community has this phrase called red-green refactor. And it means the red part comes where you create a test that where you use code that you wish already existed. And you run the test and it fails because the code doesn't exist. It doesn't do what you want it to do yet, right? So then you write the least possible amount of code to get it to change what it says. Eventually, you get your test to pass probably pretty quickly, and that's the green part. And now that you have a test that all your tests are passing, you can refactor your code so that it can be more elegant, more understandable, more readable, and you know that you don't change behavior because your tests don't fail. This is such a great idea because it separates two things that I think a lot of us kind of do at once. A lot of us try to burden ourselves with writing elegant code that solves a problem, when in fact, we should just write code to solve the problem and then make it elegant. So once you achieve something, look at your code and ask, is this code so clear that anyone can understand it, including me in 14 months? And then refactor your code to make it more explicit and understandable. All right, so I've been talking for about 10 minutes. And we've covered what refactoring is, when you should do it, and why we do it, right? I want to get into how. Because this is, like, the things I've talked about were very helpful in my journey in learning how to refactor. But the thing that really made it so much more satisfying is finding a framework that really helps you refactor. And this framework has a name called the flocking rules. And it was created by these two developers in the Ruby community, Sandy Metz and Katrina Owen. And my hat goes off to them. I appreciate these women so much because they spent years they thought there was a way that you could teach refactoring to people who didn't know design rules, who didn't know design patterns, excuse me. Because most of the advice that's out there about refactoring expects you to know design patterns, and they essentially will give you a list of things you can do, a process to go through to say, like, hey, if you want to go to this location, this is how you get there. You can start from where you are and end up here. The problem is what if you don't actually know exactly where you want to end up? And they created these set of rules, this simple framework where you can sit down in front of any piece of code and improve it by following it. So let me show you what it is first, and then we're actually going to go into a little bit of refactoring so you can understand it better. First part is you just identify what to work on. The second part is to make them identical, the two parts, what you identify to work on, and then you repeat it until you're satisfied. So again, you can take a screen capture of this if you like. It'll come back later, but I really wanted to work with some code so you can kind of understand this a little bit, so I don't have to kind of go into detail with this. So on the right, I have code that will generate the first two verses of the 12 Days of Christmas. And the first thing we would need to do if we want to refactor this is to identify what to work on. And we do that by finding the things that are most alike. In this case, we have two verses. Those are the things that are most alike. Now we need to identify the smallest difference between them. And I would suggest that it's these two words, right? First and second. Now we need to make them identical. And what's important about this part is we're going to start changing code. And so every time we change code, we want to run our tests to make sure we do not change behavior. So first thing we need to do is to create a component that will resolve the variations, right? We're going to create, say, a function, a class, a variable, anything that we can use as kind of an abstraction that can supply the variations. And in this case, we have this relationship where when our variable verse is 1, this thing that we create needs to be first. And when verse is 2, this thing needs to be second. And so we need to come up with a name to kind of fill this hole, these question marks. Because once we have a name, we can create a component and actually can create it can attract new behaviors, and it can be a thing inside of our program. This is, I think it's just going to be a simple function, and I'm going to use the word nth to describe it, right? Because if you want the fourth thing of it, fifth, I'm going to use the word nth and create a function with it. Next, we need to implement code to supply one of the variations. So I suggest we should just return first and move on. Now we replace one of the differences with a call to the component. And I keep forgetting, after each step, we should run our test. So we would replace first with a call to nth, run our tests. And this is the one that's most important, right? Because we've actually changed code that is currently working and it still works. We're good. Next, we can delete any unused code. At this point, we don't have any, so we can now repeat. If we come back to the top, it's pretty clear what we need to work on, right? We want to get those two lines to be as similar as possible. So let's jump straight down to implementing code to supply one of the variations. And we can type something like this. And if we were to run our tests, they would fail. And this is because in the verse 1, we're not supplying anything into the parameter, right? We're not supplying an argument. And so our test would fail. So this isn't great, but thankfully all we need to do in Python is just to add a default parameter, run our tests, and we're good to go. Next, we need to replace one of the differences with a call. So we will just put that into our verse 2, run our tests, they're fine. And we'll look to see if there's any code we could delete, and not so at this point. So let's go back up, identify what we want to work on. We want to make the first verse match the second verse. So we'll change that here. We'll delete any unused code, which is that default parameter. And now we've done at least our initial step towards refactoring. We could always, like I said, the one thing I love about this framework is that it's like kind of fractal in nature. You can really just sit down in front of any code. You could get distracted, get pulled away by a coworker, and come back, and you can just improve your code just by sitting down and kind of thinking about these rules. I'm excited about it. So to recap, refactoring. It's improving code without changing its behavior. It's a tool we use to improve the design of our code and to improve the communication of our code. We refactor to make code understandable and to support new directions for our code and our projects. You should refactor whenever you approach your code with new functions, with new functionality, or after you've achieved something. And these are the flocking rules, which are just, I highly suggest taking a screen capture of this and practicing this. Because the more you practice this, the more you're going to enjoy refactoring, the more you're going to just contribute value to your team. And I have this quote that really just nails this, right? By continuously improving the design of your code, you make it easier and easier to work with. But this is in sharp contrast to typically what happens, which is nobody refactors, and a great deal of attention is paid to adding new features as fast as possible. But if you get into the hygienic habit of refactoring continuously, you'll find that it is easier to extend and maintain your code. And as I've been recently learning, the way your mind works, if you can refactor code using the flocking rules, it gives your mind a chance to just kind of relax and think about higher level design. And the way that the flocking rules work, where you're doing something easy in the foreground and your mind in the background can work on design, it actually, your mind will start releasing chemicals that improve your emotions. This is some interesting research I've found with the Extended Mind, the book The Extended Mind by oh shoot, I forgot her name, but it's something really interesting that I'm excited to learn more about. And speaking of which, if this is at all interesting to you, I have some great news, because I've created a thing called the Python Refactoring Toolkit, which if you go to my website, everydaysuperpowers.dev, there's a lot of information about the toolkit on there, including the free version that has so much stuff. My research is going to go into there. So if you want to keep up to date with that, please check that out. Otherwise, I am Chris May, and I learned to program as an adult. I became a senior software engineer learning with Python, and I've quit because I want to teach people how to enjoy their lives, to have superpowers they can use every day. And please let me know how your refactoring journey goes, because I can't wait to find out. Thank you. I think I went a little fast, Denny. I'm sorry.
So fast. But in an interesting talk, it was almost 15 minutes. Oh my God, it's okay. But it was something like I was during the whole talk. Oh, he didn't present. He didn't say his present. What he is. First time I see you left it at the end. Say, who is Chris? Who is the speaker on this talk?
I
Okay.
thought I would experiment with that, because there were times where I feel like it takes a lot to get over that hump. But so I'm going to try putting it at the end just to see.
Okay, we have a question in the in the chat. Oh, shoot. What do you think about the formatter like Black?
I love formatters and tools that can help make your code more expressible, right? I feel like there's let's start with Black. I love Black. I love it came out. I technically use Blue because I'm somebody who loves the single quotes instead of the double quotes. But the beautiful thing about them is that it eliminates it helps your code just look the same, right? And so it eliminates a lot of these discussion points on teams, which can sometimes be points of contention which don't need to be there. So Black, wonderful. I love Blue. But also things, even there are programs that can help you refactor. The one that comes to mind is Sorcery. I use it in my PyCharm instance. And, I even with the flocking rules, I kind of had this sense that I need to do it myself, right? I need to go piece by piece and figure out exactly how to elegantly format this code. But then one day I was like, let's see what it can do. And it just saved me so much time. It took away the need to think about every single thing. And instead it just got to the point where now I can figure out how can I make my code more understandable. And that was a wonderful thing. So I say Black, awesome. Like any tool that you can use to make your life easier, use it. And listen to others to see what tools they're using.
Yeah. But something funny in the chat. Check. Couldn't say, I would cry if I had to maintain that code.
Indeed.
No. Don't cry. Chris can help you. And another question in the chat. And okay, it is a good tool to help to keep the code clean. Okay, yeah.
Good question. I wish I could understand that a little bit more. So is there a good tool to keep the code clean? That's a good question. I'm trying to think. There's a thought that's going through my head about I guess it depends on how exactly you want to keep code clean. So I'm going to say off the top of my head, there isn't any that I know of. I know of things that like will, maintain a certain level of test coverage. Things like Black, iSort, PyCode style will kind of help keep your code clean, but it won't necessarily help keep your code understandable. That's kind of where the human level comes in, right? So I don't know, at least that's as much as I can think of at this time.
You have some fun in the chat check. I think for the
Oh,
inspiring talk.
excellent. Oh, good.
I'm gonna show you in the screen another question for you.
Oh, okay.
Maybe it's easily to understand. Yeah. You can
Yes.
repeat it for people who is just hearing this. How do you convince non-technical stakeholder of the importance of refactoring? Yeah.
Yes, absolutely. Okay, so because there was actually something I came across that I wanted to include where this exact tension was coming up, because project managers, they just want features, right? They think that features is the easiest measurement to say if a team is succeeding, and if things are going well, right? So this is part of the reason why I love refactoring when you have a new piece of functionality, is because I find that there's this mentality that it has to take a lot of effort to refactor. We have to take, a month to refactor. Once you kind of practice it, and this is the big thing, is practicing, right? There are actually a lot of refactoring practice katas that are out there where you can kind of grow. And when you kind of just get in the practice of it, you could drastically reduce your time of refactoring. So there's part of me that says, kind of go skunkworks with it. Don't tell your project manager that you're refactoring, but talk to your team about it, right? Because if let's say one of your members of the team is working on a file that you're working on, and then they pull the latest code and look at it and it's completely changed, that's not necessarily a good thing. But if your team kind of weigh in, and they might actually be able to help you determine like the trade-offs you make for refactoring. I'm trying to think if there's any other any idea. The other thing, like if you do, because I think part of it too is a lot of times project managers are non-technical, so they don't quite understand how, like, if a code works, the code works, and that's good. But the understanding is what helps, right? If you can write code that is more understandable, the chance of you writing a bug is reduced, and the chance of you writing the next piece of functionality quicker is improved. So if you could kind of talk to your project manager on that level, it might take a little while to kind of find the right language and the right level to talk to them on. But I bet, I know of project managers who have been convinced. I wasn't there for how they figure out how they were convinced, but I think it's definitely very doable.
Hope so, Puram. This was a great answer for you. But people in the chat are asking for tips. The next 3 questions are about if you have some tips about framework, testing. But okay, let me take the question at the middle. You still have, 5 minutes. You are lucky.
Yeah.
Check, Tanim. Will new functionality also include upgrades in the underlying language, Python upgrade, for example?
Yeah, absolutely. I would say so, right? Recently Python introduced the switch statement or the match statement. I keep forgetting exactly, but the wonderful thing about it is that you don't have to like go back immediately and change your code. I think that's another misunderstanding about refactoring, is that just because something new shows up, you have a new framework or something new in the language, it doesn't mean you have to go back immediately to fix something. If it's working, it's working. You may never need to touch that code again. But if you are touching code, then absolutely take advantage of a new framework, or in particular, if you're on a new version of Python, which everybody should be pretty new, you should upgrade to Python and use the new features of that language. I've lost audio, I think, but
Yeah, it's me. It's me.
Oh,
Sorry.
okay.
It's me. The last one. Okay. Something. Okay, testing. Do you have any tips on testing frameworks?
I would say I really enjoy PyTest. I learned a lot from Brian Aaken's book on PyTest. I really appreciate how it allows you to write more Pythonic code and just insert assert statements to test your code. I am actually also doing a lot of research on testing because I think refactoring and testing are two really great test-driven development and refactoring are two practices that are really great to do, but they're very hard to learn. I think the flocking rules is an incredible framework to help people refactor. I'm hoping that there's a way to help people with testing because kind of what I've learned is that there is no one way to test your code. And there's a lot of opinions out there, but like everybody does it slightly differently. So go to my website, sign up for my newsletter, and I'll definitely like to keep you involved to let you know.
Oh, no, I think it's this. Hey, okay. Can you hear me now? I'm just.
Yeah, I can hear you.
I really enjoy your talk. And now, okay, thank you so much for your time.
Thank you.
It's
Yeah.
a pleasure having you here with we all. And now we will continue with the next speaker. Let me introduce Alison Orellana. Oh, still have 2 minutes left? Well, no. Thank you so much, Chris. Okay. Now, the next speaker. Let me introduce you, Alison Orellana. Hi, Alison.
Hi. Hi, Denny.
Are you enjoying?
Yes, I'm enjoying it.
From which time zone are you presenting now?
Here it is UTC -4.
It's from Bolivia?
Bolivia, yeah.
Latin America.
Yes.
Representing here. Okay, Alison, now we will be talking about, let me check, Alison, I forgot. Okay, basic image processing with artificial vision. Sorry for my vision. I can't see the name of your talk. Okay, let me introduce Alison. Okay, I will let you present your talk and yeah, see you in a couple of minutes with your questions.
All right. Thank you.
Thank you, Alice.
Okay, so to everyone, I'm as Denny said, I'm going to present you the basic image processing and one of the things that are important for artificial vision. So I'm presenting myself first. I'm Alison Orellana Rios. I'm from Bolivia. Actually, I'm a Bolivian software developer, computer engineer from Bolivia too. Master in design and production and multimedia production. I did some of data science and currently I am the lead organizer for PyLadies Cochabamba. So here we come with artificial vision, that it's a field that probably it can be related to artificial intelligence. So it's almost from that field. Well, it's from that field. And it allows us to obtain that visual information and to take actions based on that information. So our goal for this image processing is to improve the quality of images that we can use later for some interpretations, some analysis, and probably much more. So how does it work? And we can say that we need bunch with a lot of data to make some things, and we need to organize that information, to get that information in, to transform it, to filter it, to make that recognition on images. So we need two technologies for that, and one of it's deep learning called DL, and a convolutional neural network, sorry, that it's called CNN. So with the first one, what we does, well, how does it work? With the first one, it's based on that machine learning uses some algorithmic processes, models, to learn the vision that the computer has, the visual data. So ML, machine learning, uses these models that allows a computer to teach itself and train some of that information to use the context of the visual data. And with that information, we can use to feed a model to use more information, more visual information. And the computer then will use that information to to make a difference between which image we need and which kind of image we don't need to use. So the other hand, we have the CNN that helps that machine learning or deep learning model to be the images and to perform those convolutions, to filter the image between, well, many filters. And with that, we can have some predictions about one image or a bunch of images. And with that information, that filtering, we can have the mathematical formulas, equations, and functions to predict some what we need to obtain. That's that allows us to use that images to give some more interesting information. So, what are the objectives of this image processing? First, we need to improve the quality of the images for using them later. And some of these objectives are almost for the same, for the same objective. First, we can remove defects, like the image that it's right on the on the right. So we have an image that's incomplete, and we can try to understand what is the image, what does it mean, if it's architectural part or if it's only I don't know, just a little piece, this one. And once we have that information, we can try to add information, or in defect, by default, subtract some information. So that's why we need, that's why the other objective is remove problems or improve properties. The properties can be like that image shows us that shape, and we need to create some shape to be almost the same as the first one, so we can try to complete it. And the other one is with that to add information. So these kind of objectives let us to understand a picture, a photograph, a video that's probably incomplete. Okay, so some of the common uses for this are the identification of the images, detection, recognition, restoration, or movement. And the first one, like identifying some like words. When you see an image, you can say that it's a number or it's a letter. Detection, to once you have that image, that letter or that number, you can know what's going on. Like it's a phrase, it's I don't know, a sign or something like that. That recognition with the same, we can try to recognize colors of one picture or shapes or characters, as it's almost the same. Uh, Restoration, like the last example, and the last one is movement, like a video, which is a sequence of images. So yeah, we can try to use in many topics as we want. Some of the considerations to use the images for this recognition are the stream, the projection, information and features that an image has. For the first one, the projection, which is you can see an image from many angles, and what it seems to be as a circle could be from another side, a rectangle, or somewhere like that. Somehow it can changes. About the information, we can try to understand that if we took a picture, we can capture many things, such as light or darkness, or incomplete images, and that leads us to make some mistakes. Some of the biggest mistakes can be like, we have an image but it's not clear enough, so we cannot understand if, for example, in the image down, you can say that it's a dog or if it's a cupcake, probably. So that kind of information is really important to analyze after we capture it. Another one are the features, for example, the colors that an image has. And we can try to make the computer understand what we see. And that happens by the pixels of an image. So a pixel can recognize if that pixel has some information, like it has this quantity of red or this quantity of green or blue, and it can show us what's the real answer. But as always, the computers can't have the last answer. This image, the last one, the right, is a good example of what the human brain or human eyes can confuse some colors. It was a great discussion about if the dress is white with gold or if that image has blue and black. So with this kind of information, we can try to understand if it has more blue, more green, more red. That probably that dress is only, I don't know, maybe white and gold for the machine, but maybe it's the light that affects it. So there, with these considerations, I'm going to show you some demonstration about what we can do at the basic stage of, of what we need to understand of processing images. And here we have this one. First is this image that is the original one of pajamas. Here we changed the color. We made it negative. Here we are changing the bright, the light, sorry. And here we show it with more darkness. And here we are changing the, we are flipping it. And how does it work? We are using the pixels to make that change. So if I put it again, you can see that each of the pixels, now we are going from 1 to 1, and we are changing some properties. And with that property, we can add some light some of the properties of an image, that is light, colors in the case of the negative one. And in the other one, we are reversing it. We have a mathematical function that reverses all the pixels, and it shows again everything. So that's how it works, at a simple way to show it. And I don't know, I really like how it changes the colors, and yes, that's it seems like too simple, probably, but it can help us to get information that probably it's more difficult to obtain from an image. What if we have a sign that it's upside down and we need to understand what is going on there? So we can just flip it and recognize, I don't know, maybe the letters, the phrase that it has, or something like that. If we had an image that is too dark with not enough light, we can um, uh, add more light, and that's how we can work with images, the first steps of working with images. Some of the applications, well, I think that are probably, there are more. Actually, there are there are more than I'm than the ones I'm showing you now, right now. So first, on the industry, um, computer vision allows us to see what is happening on the environment, so we can recognize some patterns, some objects, based on the uh, quantity of images that we have trained before. And here we have the first image on the left, that it shows us that recognizes the image is showing us the recognition of a person and the helmet. The second one, we can use it like an industry, a line of production, where it looks what are the problems, if it has problems, if it's sealed, or if it's complete, something like that. And then the third one, like in the last one here, shows that it obtains the picture, and it differences which kind of element it is, material, that is, if it's plastic, or if it's metal, and this kind of differentiation, sorry, it allows us to use even in robotics. Another example, it's about medicine, and we can see on the right and in the left one, the first example, we can understand what's going on in micro images, with information such as color or shapes. Like in the second one, like if it's melanoma, or if it's just one pickle, one, one little point of on the skin. I didn't remember the name, sorry. And in the third one, we can see if that lung has a problem uh, by the shape, or probably the color, if it's another kind of examination. And yeah, we can have this kind of applications with computer vision. Here's another one that it's about transportation. I think it's not, well, in the first one, we can show how many cars are, just to see if it's a car or if it's not. In this one, is just showing which are cars. And the second one, it's the Google one, the Google car that drives itself. And well, I think it's an interesting job, because it's kind of revolutionary about the cars industry. The third one shows us that we can see and understand the distance that we have between each car or object, and that helps with the automatic self-driven cars. Yes. And the last one is like in the left, in the left, in the down left, and it's where this is working right now here in Bolivia, and we have where the cars, I just forgot the name, sorry, the cars placa, well, I don't know how to say where the number of the cars are, the numbers and names of the cars, sorry, are, and if it's uh, on the center of the city and that number is not allowed, it takes a picture and it gives the ticket of the f- the money, the amount of money that they debt to the country. I think that's uh it's named photomultas, and yeah, it works really well. So we have this kind of interesting applications that are working right now, that are really interesting, that we can use. And here is a miscellaneous will. That one comes here. We can use it as in security cameras to show if our house is okay, if it's not. The other one is to understand a picture that it's not well captured. I don't know. And the third one that I explained right before this one. So I think that the conclusions that I can give to this artificial vision or computer vision, it's the same. We can understand many information from many topics, and it allows us to improve this performance in different processes. We see that industry, medicine, sports, I don't know, it's just we need, yeah, kind of imagination to create something interesting, really interesting. The other one is to reduce maintenance time and costs, because there's no human hand in that, and yeah, it can be a great revolution in the industries. The other one is to interact with the environment, avoiding damages. We can use like a drone or other kind of cameras to capture this information without the human being present there. So yeah, it's interesting that it reduces that impact, and provides useful tools for different areas. So as we see before, we can develop many tools, much more. We can try to understand it more, to develop it in a different way, to fix some problems. And yeah, I think that's the most interesting part. We can use it in many ways. And I think that's all. And thank you for being here and listening to my talk.
Thank you, Alison. It was a great talk. And now, let me show you something. No, I'm not allowed to show you to present now. And yeah, I hope so everybody's enjoying the conference, and thank you for staying there. And we have a few more hours of talk. Now we will have an hour of break. I hope so you can come to continue with the talks. Choke, do you have some announcement or something?
Hello,
Hey.
ladies. So I'm hugging my pillow right now. So yeah, thank you so much for the talk. I really like the Pyjamas logo. That is super fun. And yeah, so what is going to happen is that so this is the end of this stream. So for people who are new to Pyjamas, so what we would do is that we will take a break, and then I will continue with another live stream. So if you have the playlist that we have sent out before, or you click and you have the playlist, so it's the next one on the playlist. Or you can just like pay attention to our Twitter and like, or you can find it from our channel that there's the next one that we're gonna continue streaming. And then Alison actually is our first host for the next one, so you will see more of her.
Yay!
Great.
Alison, you need to share the logos with us. I really
so-
like.
Yeah.
Oh, yeah,
So
sure.
So, we have, so this is all the links there. I just want to put it on the screen so people can, if you haven't joined the Discord community, join there. You can speak a question. You can chat with other people, make some new friends. There's also the raffle. You see it's like rolling there. That basically you have to get the ticket and then fill in the form, and then you get answer a very, very simple question. There's no right or wrong. And then you may actually get a copy of the Deadly Simple Python book. Yay! So please do that. And I think that's basically this is the end of the.
Stay there. Even we only go to change link, but we are still remaining.
Yeah.
In the transmission.
So changing soon, so make sure you fill up your coffee. I'm actually drinking tea instead because I don't have coffee.
I still have.
Oh, that's good. Okay. So yeah, like make sure you if you want to be refreshed, you can refresh yourself. I've done it. I've changed clothes, as you can see. I've refreshed myself, and I have my tea ready. I have all my midnight snack ready. I have a mini tapas sitting in my room. So yeah, I'm gonna have some of those, and then we will continue, and then we will have Alison hosting us, and so there are actually more amazing talk. If you want to check out what talk is coming up, so the schedule is on our our website, and then there's also other information there as well. So that's it.
All right.
Emil, it was a pleasure to see you, Alison, here and share.
Thank you. It's nice to see you too.
Yeah, no question in the chat, but okay. See you. See you. Just
See ya.
take a break, refresh a little bit.
All right.
Bye.